at our world today, the challenges are just so clear for us all to see.
Climate change, it's an existential issue and it's going to need engineers to come up with solutions.
Engineering has a really crucial role to play in helping us to deliver jobs and opportunities.
The Royal Academy of Engineering harnesses the power of engineering to help build a sustainable global society and create an inclusive economy that works for everyone. We support talented engineers and work to make the profession more resilient, diverse, and prepared for the future. We back the people behind innovative business and build global partnerships to address the planet's biggest challenges. And we provide policymakers with the best engineering advice and open the eyes of the public to the wonders of engineering.
I see extraordinary talent and passion in the engineering community.
I'm enormously optimistic about the future.
Hello, everyone, and welcome to this online conference, Key Technologies Shaping the Future, jointly hosted by the Royal Academy of Engineering and CESAER, the united voice of universities of science and technology in Europe. My name is Alok Jha, and I'll be your host for the next couple of days. We've got some of the best minds in Europe in the room, in the virtual room this afternoon. So let's kick off with an interactive poll of probably one of the most important questions we're going to be dealing with. The poll is going to appear very shortly in the box below your screens. So do have a read, get voting. And in the meantime, let me tell you a bit about myself and what you're going to be hearing in the next couple of days. So in my day job, I am a science and technology correspondent at The Economist. I've worked as a science journalist for the BBC, The Guardian for many years, and also ITV News. So I do believe that the importance of communicating what's going on at the cutting edge of research is incredibly important, and especially talking about those people who are making policy decisions. So I'm eager to see how today's research agenda influences the society we're all going to be living in tomorrow, which brings me to this event. Over the next 2 afternoons, some of the best researchers and engineering professionals from the UK, Europe and beyond will explore the trends in key technologies over the next 30 years. And we'll be asking what the impacts will be for society, what the impacts will be for our economy and our environment. Looking at 4 areas central to our societies, in particular, health, energy, education, and safety and security. We'll be seeing how our greatest opportunities and challenges are bound up with the integration of incredibly disruptive new engineering technologies and challenges, and how those things integrate into our society. And we're delighted to have so many of you joining us in this virtual environment, and we hope that you're going to find it insightful and engaging over the next couple of days. We do have an excellent lineup of speakers, and you have many opportunities to ask questions and to network with the speakers and the other attendees. So before we begin, a couple of housekeeping notes just to make sure that we're all on the same page. Now, for the best viewing experience of this event, we recommend that you go into full screen mode, and you can do that by clicking on the maximize screen icon, which is in the bottom right-hand corner of this video. To come out of the full screen mode, you can just click on the same icon. So just to remind you, the full screen is you click on the maximize screen icon on the bottom right corner of your video. To pose your questions during panel sessions and Q&As, just type your question into the Q&A box below and click on the blue arrow to send. You can also upvote other attendees' questions. If you'd rather not ask a question, but you like someone else's question, do show your love for those things, and then those questions will be more likely to get answered. If you want to comment on the conference on social media, please do so. And could we ask you to use the hashtag KeyTech21. So that's hashtag KEYTECH21, so that we can keep the conversation in one place. Let's get that discussion going. It's really interesting to hear what you're thinking during the conference. Finally, the recordings that you're seeing, you're going to be made today, will be made available on the Academy website and also the CESAER website after the event. Once those recordings have been published, we'll send you all a link so you can view them at your leisure. Okay. So I mentioned there was a poll at the beginning, and you've seen it flash up a couple of times on the screen already. The question was going to be honest, are you wearing pajamas for this event? This is an incredibly important question. And the question is, the answers are yes, 100% pajamas, or business on top, pajamas on the bottom, or perhaps you're 100% business all the time, or you've switched at the last minute. And I can see that basically this is a very, very professional audience. No one here is admitting to any sort of lax sartorial elegance here. So no, I'm 100% business seems to have got almost all of the votes and is definitely the winner. Next on the list, we have business on top, pajamas on the bottom. A quarter of you admits to wearing pajamas at the bottom. I'm not going to ask you to prove it, by the way. Just I believe you. I switched to the last minute. No, I switched to the last minute. 16% of you switched to the last minute. It doesn't say which way you switched. Did you switch from pajamas to professional wear or the other way around? I don't know. You definitely switched though. And a good 13% of you say you're 100% pajamas, and the exclamation mark says you're proud. And oh no, it's increased to 15% now. So this is a live poll. So 15% of you are wearing pajamas, and good for you, frankly. Well, whatever you're wearing, I hope you enjoy the next couple of days and are feeling comfortable. And I think that what it does show is that this audience is professional, but also we are up for a good discussion and having a little bit of fun too. So let me introduce the first section. I'd like to welcome Professor Max Liu, who is an Academy Fellow, President and Vice-Chancellor at the University of Surrey. He's also chair of the CESAER Key Technologies Task Force. And Max will tell us a bit more about what to expect this afternoon. And he'll also introduce our first keynote speaker, Professor Sir Jim MacDonald, President of the Royal Academy of Engineering.
Thank you, Alok, for your kind introduction, and good afternoon, everyone. I'm so delighted to welcome you all to this conference on behalf of CESAER and the Royal Academy of Engineering, which brings together policymakers and government and university leaders from Europe and the United Kingdom. And this is a great opportunity to imagine what the world would need by 2050 so we can develop innovative solutions. So over the next 2 days, we will explore trends in key technologies over the next 30 years and their impact on society and education for the next generation. Shortly, you will hear Professor Sir Jim MacDonald, and later the Right Honourable Kwasi Kwarteng, the Secretary of State for Business, Energy, Industrial Strategy, will be delivering this afternoon's last keynote speech. So I'd like to thank all of them and all our task force members and distinguished speakers today and panelists taking part for their insights and views in shaping a roadmap for a future that is more difficult to predict than ever. 30 years sounds like a long time away, but if we hope to be prepared and ready for the challenges of the future, we must start now to imagine what these might be. As research leaders, we must look over the next horizon, be visionary and as well as practical to help governments to shape policy for a desired future. Today's first theme is a healthy society in the next 30 years. We have seen our extraordinary experience of the global pandemic that we need to carefully consider how key technologies will shape future health systems, including public health. We face the urgent need for a resilient health system to prepare for the next pandemic, while embedding effective care and solutions for our aging population. So we need to turn to technology for answers. But recent months have also proven that technology and science are not enough, not sufficient by themselves. We must also call upon the expertise from our social scientists to advise us on culture and behavioral insights as we seek to mass roll out technological solutions, not least reflected in the vaccination process as we experienced. Today's second theme is a safe and secure, equitable society in 30 years. Here we see the pace of the accelerating pace of AI, robotics, and cybersecurity and so on. But the disruptors are also making advances. So we can be sure that safeguards against cybercrime will be in even greater demand in our increasingly complex digital world. Finally, the pandemic highlighted the digital divide in access to education and, among other things. This clearly shows that even technology changes a society, we must ensure it changes fairly for everyone, and we will simply see new social problems take root. Equal access to technology, therefore, must be the foundation for an equitable, safe, and a healthy future. So the next 30 years will hold no shortage of challenges, I'm sure. Some will be familiar, while others will be entirely new. So building productive and resilient partnerships in research and innovation will be critical to solving these grand challenges. So let us stay optimistic as we work together to shape the future for the better. So thank you very much for your attention. I wish you all a very enjoyable conference in the next couple of days. Now it is my great pleasure to invite Professor Sir Jim MacDonald, President of the Royal Academy of Engineering, Principal and Vice-Chancellor of University of Strathclyde, to address us. Jim, please, over to you.
Thank you very much, Max, for that warm welcome and for those important and insightful words. So, ladies and gentlemen, it's great to have you here. On behalf of the Royal Academy of Engineering, it is a genuine pleasure to welcome you to this joint conference organised in partnership with CESAER. I'm delighted to participate in the meeting for several reasons. I did have the great privilege of being president of CESAER and was indeed Professor Rick van de Waal's predecessor. CESAER is an excellent asset for European research, innovation and education cooperation, and it has indeed been the strong and united voice for now over 50 universities of science and technology in Europe since 1990. It was during my time as president that the proposition for this joint event arose. I would like to thank my colleagues in CESAER, not least David Beaumont and his team, and our great team at the Royal Academy of Engineering for doing all of the heavy lifting in organising this meeting so professionally. Particular thanks go from me, of course, to Professor Max Lowe, Chair of the CESAER Key Technologies Task Force, and as you've heard, a Fellow of the Royal Academy of Engineering. Because of his leadership and energy in bringing the conference together, that's what's brought us together today. And a big thanks to Rick van de Waal as well for his commitment in delivering this event. The Royal Academy of Engineering strategy is built around two key goals: harnessing the power of engineering to build a sustainable society and an inclusive economy. But to meaningful, this must be considered in an international context, particularly our goal to progress towards a sustainable society. No organisation, or indeed country, can achieve these goals on their own. Consequently, the Academy places significant importance on our international partnerships, working with the engineering community and policymakers across different countries to tackle global challenges, while continuing, of course, to promote and support engineering excellence in the UK. Importantly for this audience, as we gather together, I would say that for the UK, leaving the EU does not mean leaving Europe. Continued partnership with a strong European science and technology community is essential. We are therefore incredibly pleased to be working in partnership with CESAER, an organisation where UK and EU voices can meet and cooperate on long-term issues rather than be distracted by short-term competition. Our conference today is an excellent example of this. We are bringing together engineers, policymakers and other thought leaders from across Europe and beyond, and addressing some of the biggest challenges of the next 30 years, such as Max mapped out earlier. The programme has been designed in the context of the UN Sustainable Development Goals, exploring how engineering and innovation must play a crucial role in meeting these ambitions. And for the conference, we've grouped these under three main themes: a healthy society, a safe, secure and equitable society, and a net zero world. Of course, for engineering and technology to deliver this future, we need to ensure that our engineering community at all levels, career stages and across sectors is inspired and equipped with the skills that they need. And this is not an insignificant challenge. Our last session in the conference will therefore focus on the future of engineering, learning and teaching, exploring how we can deliver an engineering workforce fit for the 21st century. And while collaboration across Europe is essential, it is not sufficient to tackle these challenges, which are global in nature. So I'm absolutely delighted that we have global dimension to this conference also, looking beyond European borders. And this is strongly aligned with our Academy's focus on broad, deep international partnerships for global sustainability, including with the Global South. Such partnerships will be increasingly important over the next 30 years, and we hope today's conference will indeed be a rallying call to the UK and EU engineers and policymakers to work together, and of course also to work globally to ensure innovation and technology deliver the maximum benefit for society in the coming decades. I'm delighted that we've come together today, and I'm sure this will support the development of an already strong set of collaborations between CESAER, its partners and members, and the associates in the UK. Ladies and gentlemen, please enjoy the rest of the conference. Thank you very much indeed.
Well, thank you so much to both of our opening speakers. Some really inspiring words there, and it's really good to get into all of the topics that they mentioned. So our first session is on the future of health and healthcare. And before I introduce it, let me tell you there's going to be another poll. So you'll see there's a poll coming up. The question is that by 2050, will emerging technologies have demonstrated success in extending average healthy human lifespans? Have a look at those questions. Have a look at you and think about how you might answer it. Now, new technologies and new medicines promise improvements in human health that probably would have been unimaginable decades ago. But how close are those new technologies to becoming realized? And can they be rolled out in an equitable way? These questions are obviously incredibly apt right now with the development of brand new vaccine technologies for the pandemic and the way that they're being rolled out around the world now. There's still a long way to go. The question we want to ask is, can new technologies help us with the less glamorous but arguably more important challenges facing society, including managing our health systems for a population that's getting older? So the poll, let me remind you what the poll was. The poll was that by 2050, will emerging technologies have demonstrated success in extending average healthy human lifespans? The answers possibly were no, this will always be impossible. B, no, we will be closer than ever to the goal. C, yes, they will extend human lifespans, but in ways which benefit the super rich only, always a concern. And the final option was yes, they'll extend lifespans, but in ways that promise extended healthy lives for all. That's the optimistic option, I guess, isn't it? And I'm just getting the answers in now. So far, well, as might be expected for this audience, most of you think that by 2050, emerging health technologies will have demonstrated success in extending human healthy lifespans and will have done it for the extending healthy lifespans for all. 68% of you think that the technologies will be available to everyone. Another 26%, 28% of you and rising think that it will only help the super rich. And the people who are less confident about the future, about 10% of you, 9 or 10% of you think that the healthy lifespans won't have increased necessarily, but we'll be getting closer. And 3% of you, interesting, 3% of you think that extending healthy average lifespans will almost be impossible. But, 63% of you, 64% of you now think that there'll be healthier lifespans and they'll be accessible to all. So I think that's really interesting. Shows how you lot are incredibly optimistic about all of this, which I think is a good frame of mind to be in. Now, to open up the session, I'd like to introduce Professor Jackie Hunter. Jackie is a Fellow of the Academy of Medical Sciences in the UK and a Director of Benevolent AI, which is an organisation that uses artificial intelligence to improve all stages of pharmaceuticals research and development. So, over to you, Jackie.
Thank you very much. It's a real pleasure to be able to introduce this topic today and the speakers, because I believe that technology is going to have more impact in terms of health and wellness of humanity than it will have in many other sectors. Of course, predicting the future is never easy, and what it will look like is always very difficult. But that's what we've asked our panel to do today. When my co-chair, Chris Luberman, and I were discussing this topic, we realised that the huge breadth of potential opportunities and the absolute depth of need really meant that technology is going to have an impact on many, many levels, from the augmentation of human capabilities through robotics, which Professor Gordon Cheng will address, down to the molecular level, where we can use the ability of AI to really augment human drug design for therapeutics, which is going to be talked about by Professor Gisbert Snyder. At an even more micro level, Professor Ewan Burney will consider how developments in genomics and genetics are going to have a major effect on health and wellness. Of course, our aim is to really use things like machine learning and AI to create machines that can emulate human intelligence. And the effects of machine learning on image processing will be the focus of our first speaker, Arlindo Oliveira. The policy and ethical challenges in this space are, of course, enormous. And so is something that we're going to be coming back to in the questions that we have. But it's certainly something that Tim Mahler and his colleague Annika will address at a systems level with regard to looking at the implications for brain-machine interface. So, we have a very packed agenda, and I would like to kick off by asking Arlindo Oliveira to give his 5-minute vision of the future. What was it going to look like?
Hello, thank you for having me in this very interesting meeting. I'll try to give you what I think will be the next developments on the applications of artificial intelligence in the health domain. I view these applications in 2 dimensions. One of them is data analysis, and the other one is automation of human functions. And I think we can somewhat separate it in this. I mean, there are many applications. If you want to organize them somehow, I think it's useful to think of this. So data analysis, which of course is probably the most important application of artificial intelligence these days, is this idea that you can integrate data and use this data and extract value from that. In medicine, in health in particular, I think the integration of genetic, behavior, and clinical data will move us towards precision medicine, or it's common to say now, P4 medicine: predictive, preventive, personalized, and participatory. So in the idea that you can move the medicine from this one-size-fits-all that is the rule today to a much more predictive and personalized medicine in the future. And we will move towards that with the analysis of very large troves of data that is available in many places, in particular in electronic health records. And this will enable us to discover new treatments, to repurpose drugs, to find and avoid drug side effects, and also the best drugs for a given genetic characteristics of the users. Then you can also use it by mining this data. You can also use it to predict the functional outcome and the risk of specific diseases, stroke, tumors, heart attacks, and other cardiac conditions, and so on. And you can also use it to optimize the logistics of hospitals. So I mean, this idea, this is if you want Industry 4.0 applied to health. We have been facing severe challenges in handling the pandemic in Portugal, as in many other countries, and a lot of that was related with logistics. So moving patients between hospitals and all of that, making sure that all the resources were fully used. I think we were somewhat We're not professional in doing this, and certainly AI and new platforms will optimize this very much. Then the second dimension is this idea that you can automate a lot of human functions. And here I'm thinking about a lot of diagnosis that is being done on medical images. Right now, these deep learning methods are approaching, in some cases even overtaking the ability of human experts in the analysis of medical data. We can now segment and classify tumors and other conditions such as skin cancer or breast cancer at the level of an expert. This is particularly useful in countries, in places where you don't have doctors available, you don't have specialists available to diagnose skin cancer or to diagnose other illnesses from images. And yet you can, in some cases, for instance, for skin cancer, you can actually get these images very easily. You can also segment and classify the severity of a number of other diseases like stroke. For instance, we participated, so we developed an algorithm to classify what will be the severity of the effects of stroke victims, and we could predict with unprecedented precision what are the effects 3 months in the future, given only the information that is available when the victim enters the hospital with the test that he or she does when they enter the hospital. And also we can also improve the state of the art in automatic in diagnosis of several heart-related conditions such as stenosis, stroke, coronary artery disease, aneurysms, and so on. So I think we will complement and in some cases supplement or even replace the functions of experts that are in many countries are not in enough number to give the attention and the care that each patient requires. And of course, in a more distant future, I think we'll also have robots doing surgeries and AI-based doctors that will interact with patients in natural language and do a lot of the work that doctors do these days. As you know, doctors don't have enough time to interact with each patient, and we can sort of amplify that time by using AI methods. This is sort of what is available with today's technology. I mean, we can do this. It's mostly a matter of doing some further developments in machine learning and deep learning, coupled with the availability of more and better data sets. But I mean, we can do this today, basically. We just need to do some more work with the technology that is available today. But I anticipate that in the next decade or so, we'll also see qualitative, disruptive developments in machine learning. What the systems today can do, they can only basically perform associations. You can associate an image with the condition, you can do a diagnosis from an X-ray or an MRI or whatever, but you cannot, the systems cannot do things, cannot move up in the ladder of causality. They cannot think what would happen if we do this intervention, or what would have happened if we did this, what called so-called counterfactuals. So moving from association to the ability to analyze.
No, I'm afraid you've overrun your time already a bit.
My last sentence. This was my last sentence. So moving up the ladder of causality from association to intervention to counterfactuals, I think it will get the next generation medicine more available and closer to the people. Thank you. I apologize.
No, and I think we're going to be looking at some of these things later in terms of our discussions, because I think it's going to be absolutely fascinating. Ewan, you're next.
Great. Well, thank you very much for giving me a chance to talk here. It's great being an engineer, not a geneticist, as I normally am. So just to talk about the future, the near future, a bit like the William Gibson novel, is unevenly distributed. And so for much of the world, you can see the near future in this space, I think, in two countries, Denmark and the UK. Denmark, for the remarkable dedication they have done since the 1990s of having detailed electronic health records available for research and healthcare delivery. And then, and that is actually 10 million Danish people that's accessible for research and for healthcare practice investigation. of which 5 million are alive, and another 5 million sadly died before this year, certainly. And it just shows you that these data sets are feasible to generate in scale. And one interesting thing about that future is that there's some pretty good 1970s statistics, like there is in a lot of AI and machine learning, linear models or Cox proportional hazards or other things. But you do need them to scale. And so you need these new techniques of scale out systems that use GPUs and other things. The second near future that I want to introduce you to is the one in the UK. And that is with the genomic medicine service there called Genomics England, and its equivalent in Scotland and in Northern Ireland and Wales, where now in the NHS for certain disease classes, often diagnosed very early on in the first weeks of life, doctors can ask for a genome sequence. And that genome sequence is very useful in certain circumstances at the moment. Now, this in some sense is just like an image. So it's a sophisticated method of measuring something about humans, which we can then use in medicine. And I actually see a real analogy about the way that imaging techniques like X-rays came into medicine in a similar way for genomics coming into medicine. Of course, X-rays 100 years ago and genomics are now. But it's exciting because these data sets are the data sets where you can derive more information over your life course. And therefore, doctors can think more proactively about how to think about prevention or think about testing, screening a subset of the population where that screening will be much, much more beneficial for that and with less harm. One of the complications, as I'm sure many of you know, is that screening can give many inappropriate harms because you just worry people as well as it being expensive by misdiagnosis. So what is the further future of that? Well, I do think this wonderful world of AI methods from deep neural networks on images and deep neural networks in DNA and in protein, the amazing work of the AlphaFold group, for example, of using deep learning to discover a really unsolved biological problem, which is the protein folding problem, shows that there's a lot of opportunity. And of course, we've got to do this in a way, as ever, that is with society, for society. But I see the upside way, way bigger than the downside. The downsides must be guarded against, legislated, controlled. But there is a bright future for using genomics in all sorts, electronic health data, and artificial intelligence in the future.
Thank you, Ewan. I think the future in this area is really fascinating, and I think we'll also come on to talk about some of the ethical questions later. Gisbert, would you like to give your vision for the future?
Yes, thanks very much, Jackie. First of all, I have to say that the discovery of new drugs, a topic I will address, and medicine development are long, arduous, costly, and to some degree serendipitous processes. This is clearly reflected in the limited number of marketed medicines that are currently at our disposal. In fact, approximately 90% of new drug candidates fail during clinical development because of lacking efficacy and undesired side effects. We simply have to concede our limited understanding of molecular pathology. Now, aiming to safeguard sustainable future drug discovery, science management needs to address the following key question. How can we avoid poor decision-making in the early phase of the discovery process and select the best molecules for further development? Today, we're speculating about the future. Please allow me to say that process in science and innovation is never a result of scientific discovery alone. It also requires other forces: persistence, crusading journalism, politics, and an appropriate mindset. One such feat I would like to highlight is the integration of AI into pharmaceutical drug discovery. It took more than 25 years for those ideas to gain a foothold in a comparably conservative industry. The central theme of applied AI here is to partly transfer decision-making from the human science manager to a machine intelligence that generates new molecules with desired properties from scratch. As a result, innovation will no longer depend on finding new drugs, but innovation will to a considerable extent be fueled by a plannable engineering process. We're turning science and art into engineering. In my opinion, this approach is here for good and will change this industry forever. The most recent developments are miniaturized, fully automated design, make, test, analyze cycles that are guided by a learning machine intelligence. This AI software learns from the chemical structures of known drugs and known reaction schemes for their synthesis, as well as their bioactivity. Similar to AlphaGo, these algorithms play what-if scenarios, virtually generating, testing, and selecting new molecules. One could say AI gamifies chemistry. We and others have demonstrated the capabilities of this in silico chemist in prospective studies. With a greater than 50% success rate, the computer-generated molecules are synthesizable and biologically active, as predicted by the machine intelligence, thereby augmenting human intelligence, the intelligence of a chemist. Next generation technology will further increase this predictive accuracy. Now let me summarize. These lab-on-chip prototypes of the lab of the future, I foresee popping up in the next 10 to 20 years everywhere. I envisage largely autonomous discovery labs. Bespoke drug candidates will be identified in the shortest possible time. Experiment planning will be performed with AI, and the experiments will be executed by robots. In 30 years' time, we will be able to rapidly respond to emerging health threats and develop bespoke medicines for dedicated patient cohorts. So far for the optimistic view. But let's not be fooled. Drug discovery means interacting with an adaptive biological system, the human body, and we cannot expect perfection from any artificial intelligence in this regard. This is my 5 cents. Thank you.
Great, Gisbert. Thank you very much for sharing those insights. And I think it's going to be interesting in the implications of things like patentability, if the machine is doing it rather than the human inventive step. Tim, you're on next, I believe.
All right, thank you very much. So wanted to talk a little bit about really 2 topics that surprisingly are related. And that is virtual reality or augmented reality and brain-computer interfaces. And a little bit about where I think each of these are heading, and then some higher level considerations that apply to both. With AR and VR, one of the interesting aspects there is you've got billions of dollars, hundreds of billions of dollars, regarding research and development from the entertainment industry. And the question, one question for me is, how do you leverage that for other uses, health and otherwise? And now you're starting to see that. You're starting to see, quote unquote, serious applications of gaming technology and AR, VR become deployed, disseminated more readily. And it has many applications that I think you will see grow in the future beyond entertainment. And those include training, I think is perhaps the low-hanging fruit, so to speak. Fundamentally viewing information. So we have across the world access to much more data, as I think has already been mentioned, much faster. How do we digest that as individuals? And AR, VR is yet another way to do that. There are increasing applications for cultural awareness, which as the world becomes smaller is increasingly important. How do I walk a mile in someone else's shoes? And VR can let you do that. Situational awareness, perhaps less applicable to the medical industry, but nonetheless, growing potential use for VR. And then many, beyond just training, I think VR is starting to see sort of clinical applications in the health industry, certainly for post-traumatic stress. There are a number of R&D efforts looking at having somebody walk through a traumatic incident using VR. So those are some applications I see in the future for VR, frankly, that are available or are maturing today, but will be more mature in the future. With respects to brain-computer interface, certainly prosthetics, some very exciting work going on, leveraging this technology to sort of tap into or connect with the human brain. Just recently, out of Johns Hopkins, some work where someone fed themselves for the first time in their life. And then within the last week, I think, was not only able to do that, move artificial arms just by thinking about it, but could feel with those arms, could tell the nature of the thing they were touching. So that's really cutting edge capabilities. Additional work that is maturing, cortically coupled AI. So now where AI is trained or data is provided to a machine learning algorithm from my brain. Data transfer to the brain, which is a long ways away, but not as far as we think. There has been work, granted in a very controlled lab setting, where someone can send a thought literally across the internet to somebody else using non-invasive machinery. Very, very basic thoughts like left, right, but nonetheless, that's possible. Certainly data transfer from the brain and direct system control. You can buy toys now. You can buy off-the-shelf systems where you can put on a headset and think about it and control a drone. The implications for that to scale in the medical industry and elsewhere are really significant. With BCI, the work that's going on really is higher fidelity data transfer, new neuro connections, connecting with something that you've never had, perhaps born without a particular limb or capability, wireless data transfer to and from the brain, and archiving cognitive performance, which of course has some serious implications. All of this, I think, very briefly, as I hit my last minute here, have a number of things that we should consider. I think it's difficult to predict the future. Here's where the tech will be in 10 years. We're pretty good at being wrong about that. But I think it does stand that, one, the end user will be involved. So it's best for us to consider him or her as early as possible, which is a ball that's often dropped. Secondly, I think it's important to consider policy, to be proactive in considering policy. Again, that's an area I think we often fall short with emerging technology. Trust, in as much as we're talking about how we access, store, govern, use data, trust from the public will be something we have to address, and that often is dealt with most effectively by informing them, having more transparency. And I think continuous evaluation, having these discussions and assessments of emerging technology continuously is very important because it will change. This discussion will be a little different 3-5 years from now. And finally, thinking of these things like AI and VR together. The greatest impact comes from these synergies and when they're combined as opposed to when they're siloed. Thank you.
Thank you, Tim. Yes, and I completely agree with that. There's been some very interesting work as well with helping people understand. That brings us to our last introductory talk from Gordon Chang. Gordon, over to you.
Okay. Thank you so much for the invitation. I'm glad to be talking to you. I have to say, my background, I am an engineer. I started 20 years ago as an engineer, and I built robots, and it's a complex system. And the type of robot I like to build, it's humanoid robot. And these are some of the most complex systems that you can actually target to build. And these systems require, something like 50 way of hundreds of way of actually controlling such a very complex system. And I got frustrated one time and then switched. I opened up the field and then I switched over to neuroscience. I think the brain can teach us a lot on how to control a robot better than the standard engineering approach. Please don't take offense to this. So we started doing a lot of these. We built lots of very complicated systems, and by modeling the brain. And one of the key technology we just finally cracked is artificial skin. The human body has 5 million receptors. And if we use a standard engineering approach, we fail. People have been trying this for 30 years. And recently we remodeled the whole thing and then used a neuroscience approach and allow a better solution to allow an entire humanoid robot to be covered with skin. And if you think about the implication of this, now that the robot do not need a fence anymore, it does not need a cage, then you can actually have them out assisting people, helping people, right, and then work side to side with people, right, and then keeping safety with such a technology. And the other things I want to touch on is I think Tim already mentioned brain-machine interface. He called it brain computing, I call it brain-machine interface because we want to connect to the machine. This is another way of actually controlling a very complex system. Because a lot of still the standard engineering approach do fail when we increase the degree of freedom much and much. So some of the example I want to give you is about 2014 we made a exoskeleton training 8 patients with spinal cord injury, with brain-machine interface and a full-size exoskeleton. We trained them to think walking. And we trained them to think stop, and we trained them to kick. And then we demonstrated this in the World Cup in 2014 as the opening. The opening was a nice triumph, but the scientific part was even more rewarding for us. Over the whole year, the patients started showing some sign of recovery. And this is very promising. This is something have a big question mark for us. How do you interface with robot better? And how do you interface with the brain better? Right? In actually providing such a societal impact. Okay. And also, I think I just did an experiment yesterday with a patient with ALS, and he was able to feed himself. We gave him a fork. He did not have any hand movement, and we put an exoskeleton up in him. And we let him feed himself with a piece of cake. And this is after about 4 years of the disease. So these are very rewarding attribution that engineer, neuroscience, and a lot of the common technology that can fuse together to actually benefit society. And I think this is one of the key endeavor I think we should be targeting rather than purely looking at the technology. But we need to actually bring in the societal impact to actually see how we can actually benefit the overall society. Okay, and I just to the last 30 seconds, I've been saying this to all my students for the last 5 years. I'm not targeting one patient. I want to target 20 million patients with sensory motor defects. How do we do this? And these are the challenges they have to face. These are the new generation of engineers that need to think about how does their technology impact society. So I'll just finish there. Thank you very much.
You're on mute, Jackie.
we're going to thank you very much, panel. We're going to be moving to the moderator discussion now, and Chris and myself are going to be working with the panel and also using the questions that some of you have sent in. There are clearly some very common themes around AI, its use, its integration, the importance of engaging the user and society more broadly, and the integration of different technologies and their contextualization. Okay, Chris, do you want to...
Thank you very, very much, Jackie, and thank you, panel. This is fantastic. I do have one kickoff question, and it is, how much of this is truly going to benefit all, and how much of it really is going to benefit those at the tip of the pyramid? How much is this dependent upon the financial capability of an educational system, of a health system, versus really benefit for all? And can maybe Arlindo, well, you were talking about some of that. Is that the complementing, supplementing experts?
Actually, I think it will be actually both. I mean, some advanced techniques, I mean, the ability, you can sequence your genome or genotype, so on, and then you can, of course, buy services, and that will be available only for a small minority. But on the other hand, you can also democratize medicine by having these systems that will put your doctor in your cell phone if you want to diagnose a skin cancer or something. So I think it will be on both sides. I think a few advanced techniques, I mean, this data integration where you handle a lot of stuff, this will certainly benefit mostly the top echelons of society, but I think there'll also be some good news for the other sides.
Great, thanks. Tim?
You know, I think with many of the technologies we're talking about, with time, they tend to deploy and distribute across more people. It's more broad audiences. I think when out of the gate, obviously some of these things are more expensive and sure, available only to a few. But even with BCI and VR, the brain-computer interfaces.
Thank you. Yeah.
Again, that's commercially available. You can get a very, very basic system for inexpensive. And it's incorporated, like I said, in basic games. So these things, with time, I think deploy more broadly and really have an effect and have an impact on society. Well, more to say, but that would be my first feedback.
Okay, great. Thank you. Gordon, you were up next, and Jackie, then Annika, then we're going to go to another question. Gordon, you're on mute.
Sorry. I think I like the benefit part. It is very hard for us, especially the nerdy engineer, right? We like technology and we forget that what is the technology benefit for, right? And a lot of the difficulty is affordability. I think Tim touched on this. You can buy some of the very rudimentary brain-computer interface devices now, but the actually full-on system, it will be very costly. And also the robot I built, I have to say, I win the lottery for research. They are in mega millions. And I think the technology needs to be affordable. And that's the whole direction we're shifting now, to actually make the technology affordable for people. And I want to just say that you mentioned education. I think the difficulty is that we found a lot of engineers stay in engineering. Right. When I say, can you talk about the brain? How does the brain work? They're interested, but it's very hard to educate the dualism of engineering and science. I'll just stop there.
Okay, great. Thanks, Gordon. So you're pleading for some of the cross-fertilization across our disciplines, especially when we look forward to the next 20 years, as we're totally looking out to the key technology for the next 20 years, we're going to need that cross-fertilization even more and more and more. So I think that's something I know we had a lot. So Annika, can you go a quick comment and then... Jackie,
sure, yeah. I just wanted to say there are some circumstances where actually technology adoption happens more rapidly. For example, mobile records in terms of health, where there aren't any, in situations where there is no system to disrupt, it can be much easier to adopt the technology than in established ways of doing things.
Fair point. Actually, guys, what Annika, thank you. Sorry for my mix-up there. Got to keep it straight.
No, I think it's a really important point to raise, and I think particularly when you're looking at more complex systems, you know, the exoskeleton, for example, for someone who's a quadriplegic, or, you know, you could see a great deal of disparity there in terms of people who are able to afford those kinds of systems and then those who are not. I would also add to the mix the question of trust in terms of user adoption, which is one of the issues that Tim and I explored in our recent RAND report. But, you know, in the case of BCI in particular, but also artificial intelligence, there's still a great deal of public skepticism about these technologies. And so, you know, there's going to be sort of a wave of early adopters, and then there are going to be a good amount of the population that's going to want to wait and see what it looks like.
It's often said, very interestingly, that change happens at the rate of trust. So if we don't trust, it's not going to change. I think that's something for all of us when we're thinking about these different things. And then, I have a question for you about the genomics. Now, this is my pure ignorance. If I did a test when I'm as a baby or when I'm born, and I do it when I'm 60 years old, is it going to give me the same results, or do I have to get these tests done every 5 years?
Yeah. Well, there's a couple of different answers to that. One of them is, what is your definition of the word genomics? But for the genome that you got as a zygote, pretty much none of it changes. So the test that you do when you're a baby is still very useful and valid when you're 60. However, even that genome does change, and when it can change for entirely healthy reasons, and our immune system deliberately messes up parts of its genome in places, and we can sense that. It's a way of sensing the immune system. And of course, cancer is very often about a genomic defect. So by sequencing blood, for example, you can see blood cancers maybe 5 years before they become aggressive. By sequencing circulating DNA in your blood, where a lot of cancer tissues leak bits of genome, you can detect cancers earlier. So that's now using a genomic assay to see whether something's gone wrong. But many people, just to add to this, often use the word genomics also to mean other genome-wide assays. So these are types of molecules that we can measure comprehensively. So this is called metabolomics or proteomics. In some sense, the immune system is one example of that, and transcriptomics. And those very much are the things you have to measure every time. They're a bit like glucose, except it's not just one measurement. It's like 40,000 or 200,000 at a time. And so those are much more continuous.
Okay.
And I don't know how much extra to add to that, but it's a wonderful world.
That's great. No.
Measuring humans at this molecular scale is a great thing.
I think so, because we're talking about key technologies for the future. It sounds like for all of us, it was a sort of a collective agreement that this is going to be part of our arsenal as we're looking forward. More whether it's... Go ahead, Jackie.
I was going to say, one of the things that struck me is actually all the panelists really have talked about things which, a lot of which is here and now in terms of the fundamentals. So we could print 3D manufacturing medicines that contain the right personalized combination of drugs for people, etc. Why aren't we doing that? What are the barriers that are stopping us from really adopting and more widespread use of these technologies?
That's a great question. Who wants to answer that one? All right, Ewan and then Gisbert.
Yeah, I mean, it's a piece of advocacy in my own area, Jackie, that I do. And one of the things that links to this trust aspect, healthcare systems really have to bring it in-house. And of course, then you're left at the mercy of the kind of glorious diversity of healthcare systems that are in the world. So there's a particular process of the way the NHS does things. You know, America, it's just, how to put it, gloriously diverse in inappropriately complex ways. And then you go to, for example, Denmark or France in their own systems. So this goes back to a really interesting for me piece of history of medicine, which was the realization and then adoption of X-rays into medicine. And this took 30 years. It took 30 years from Röntgen's picture to routine use. And now we have these kind of medical disciplines called radiology and stuff like that. So medicine really internalized the technology for it to be used. And I think for a lot of these other technologies, really that path, it won't be one-to-one. It's not going to be a complete similar transition, but that sense that medicine must internalize the technology, I think, is the way that this happens.
Thanks, you, and that makes
if I may add to that, just
of course, go ahead.
Yes, I mean, I'm entirely in agreement with this. I mean, there are protocols, there are procedures and so on that need to be followed and changed slowly. And then there's also the knowledge that the medical community has about this new technology. I mean, the new techniques are changing rapidly, but the doctors change more slowly, right? Because you need a whole new generation in some cases to adopt these new techniques. So I think part, of course, I mean, we don't have all the technology today. I mean, we need to develop a lot of it, but part of it is also the health system adopts it relatively slowly because you need to change the mindsets of mostly the doctors.
I think that comes back to that issue of trust. If you trust it, then you're going to change because you trust the things that you know. But I think Jackie's question about what are some of the barriers to trust, knowledge, opportunity, and just for the call it the evolution. I know Gisbert, you had something, and then Tim, I see your hand in there. Gisbert, what's holding it back?
What's holding us back? Well, I think it's mindset and a certain being used to the way things are being done. So whenever there is a bleeding edge technology, and we're talking about the new things today, it will take, I'd say, a generation to see these new technologies as mainstream. And like you said, it took... Come again?
No, that was...
Okay. No, and I mean, we have to let go of our beliefs in part. And this just takes time, and not everyone's willing to do that. And here we come back to the trust issue.
Mm-hmm. Yeah, that's a very good point. It's that sort of this hesitancy. I think that sometimes it's more than trust. You know, there's this issue there. But okay, Tim.
So I had two thoughts about this. One, when it comes to trust, I think a big way to a primary way to overcome that is transparency and communication. I think increasingly the developmenters, the practitioners, the researchers now have a responsibility to communicate to a broader community, not just our peers. The journal article is not enough. I think it becomes more important to communicate to the public, to teach the public, here's what's really possible and not possible, and that can help to break down the trust. And a complementary idea here is this idea, the idea that with an emerging or new technology, there's a push and there's a pull. Often, the developers might push a technology because it's cool, it certainly has some value. There also has to be a pull from the end user, from the public. I think VR has been interesting in this respect, that it came first from the entertainment industry. So there's a massive pull. Let me get more of this. So then when it has a serious application, when we look at a virtual environment, a game for training, I'm already familiar with this. I trust this. So I think that provides, it's not necessarily directly, those lessons learned don't directly port to the complex medical industry, but there are nonetheless lessons learned there, I think.
So it's really an issue of familiarity, right? So you're familiar with, there's a familiarity with that technology. It's not something all of a sudden quite so foreign, which is quite fascinating. I think that's part of it.
I think that's part of it.
But if I think of what Gisbert was describing with the lab on the chip, where you can be able to do these things, that sounds like mysterious. Some of what you guys are talking about doing, and gals, is quite mysterious. Now you can't see it. It's sort of like, and so then the question, you're asking the public to trust something which it's like almost beyond comprehension. So when we're looking forward, what advice would you give to the European Union, the UK, as we're looking at policy do we have to? What advice would you give us on and when we're looking at these kinds of things, as you're trying to demystify to help make it transparent? What can we do there? I guys have any brilliant ideas?
I think just to recap, what I was getting at before is it's a matter of communication on different levels. I really think scientists have a growing obligation to not just publish and communicate to the peers, but to the public of here's what's possible, not possible, here's how it works. There's different kinds of publications, different types of appearances. I think that can go a long way.
But scientists don't get credit for publishing something in the rags, right? So why should you do it?
That's a tough one. The incentives. It depends why you're in the game. Are you really there just to get more publications and more money, or to make the world a better place? I'm not naive, but I think there's a little of both that could foster.
Okay. I didn't mean to put you on the spot with that, Tim, but I mean this is something which I think we've discussed amongst ourselves, or I say our communities, how we can help make sure this communication is happening in ways that is beneficial for all. And I
do think we ought to sound a slight note of caution, because there are, of course, and not among this esteemed group, some scientists you wouldn't want to actually push them to really communicate.
I don't know what you're talking about, Jackie.
I know, my daughter always said I overcomplicated things when I try to communicate. So, it's that sort of thing, I think.
That's fair point. So, Gordon, you have your hand up, and Annika, did you want to come in on this, or is your hand still up from before?
Sure, yeah. No, I would just quickly say that one of the things that we've done at RAND is sort of rigorous red team testing and making sure that we really are quite clear about the potential vulnerabilities posed. There was a question earlier I noticed in the chat about cyber attacks and cybersecurity, and certainly as we rely more heavily on artificial intelligence, the Internet of Things, and brain-computer interface technologies, that will be a new vulnerability. But I think that governments, we typically think within the national security sector, but elsewhere as well, can do rigorous testing for potential risks and vulnerabilities and then publish that as a way of building trust.
Okay, then Gordon, you wanted to come in, and Jackie, you've got something you want to move on to.
I just want to follow up on Tim and Jackie's comment. I think the communication is really, it cannot be a one-way communication. It needs to be a dialogue that we have to have. Mm-hmm. And it's not just about scientists explaining to the general public about their work. It needs to be about the benefit of their work, right? And then drawing in the society, right? I think there's open house, entertaining politicians, right? It's needed. It's really needed, because they need to think, right? Otherwise they're just 10 years behind us in their thinking. So I think this dialogue, it should be a dialogue. And I do agree, some of us should not be communicating our work. It is not that simple, but we need to have it, and we need to actually have it in not just within a general public. We need to talk to the other disciplines. When you're working with doctors, working with patients, we need to really learn how to communicate our thoughts across and what is the benefit to them and the society. I'm an idealist, Tim. I want to change the world, make it a better place. So that's why I'm doing this.
So there are a couple of questions from the audience that I'd like the panel to consider. One is, given what you've just been saying about talking to other disciplines, and obviously these technologies will change existing roles and even perhaps existing sort of sectors. So do you think the funders of research are sufficiently adept and agile at supporting these developments? And if not, what should they be doing that they're not doing now? And secondly, for those who are thinking more about AI, fundamentally, what are the differences between, from a policy or regulatory point of view, that need to be considered if you're looking at AI in terms of health and well-being versus AI in transport or climate change or whatever?
Okay, so who wants to have a stab at it? Agility, and then the AI in healthcare.
Ewan, I think, spoke his hand up.
Ewan, do it.
Yeah, I think one of the, to the funders, I think it's something that I think many funders know, but they don't necessarily know quite how to do it, and that is funding team science and multidisciplinary research, which really works and isn't actually, one side being in charge and the other side kind of coming on board, either way around, either the clinicians or the technologists. So proper team science, real proper team science. And recognizing it, being able to recognize team science in the different ways we think about science. And then your question about AI, I think one of the interesting questions about AI and in general is in healthcare is that we have very, very complex heterogeneous systems with a lot of variables. And therefore, this problem, which is this very generic, generalizable, does this generalize question, which you can answer better in many other settings. In other settings where you can run experiments, you can gather more data, you can artificially stress test systems, you can put your system into difficult situations and see how it responds. With medicine, some of those things are much harder to execute because you're really talking about people and the cloud of variables around it. So I don't think those are insurmountable at all. I don't think they're somehow, AI is somehow a different class of problem from other medical technologies that we have. But it comes with this huge, serious health warning. Do you understand if your model generalizes? And because in AI, very often we know things work on data sets, but we don't have confidence about precisely why it works. The extreme being AlphaGo and AlphaFold coming up with systems that humans were not able to in the Go in the game strategy and AlphaFold for folding, just shows you that one needs to treat that problem with a really serious process. And I think we're going to need to have some kind of trial/regulation which fits well the setting. It doesn't take forever, but also we can't just say, well, it's working in hospitals and off we go.
Tim, you've got your hand up as well.
Just perhaps not an answer, but a comment on that first. I lost my train of thought.
Well, we can keep going. You can come back to it.
The funders, Tim.
Oh, on the funding, excuse me. So now and probably more in the future, you're starting to see, at least in the States, more R&D funded by industry as opposed to the government. And I think that has some implications, certainly in terms of agility, which was part of the question. Of course, it also has some implications in terms of incentives and goals. But I think you will start to see in the future more agile adaptation or shifts and moves in terms of where and how the funding goes. But you also might see kind of the touch from industry pursuing or the motivations behind that.
Okay, so I want to change the question. There's another question which came in, which I'm very intrigued by, Jack, if you don't mind if I'll pop this one, which is how will some of these technologies like AI, machine learning, lab on a chip, et cetera, change the roles of researchers, doctors? Because one of you mentioned, I can't remember exactly, you said we're going to replace or supplement or supplant doctors, because now we're going to just have it on our phone. We don't need them anymore. So how is this going to change? And Gisbert, since you did lab on the chip, how do you think this is going to change the role of researchers, developers, doctors?
Well, researchers and medical doctors certainly are a different breed, a little bit, to some degree at least. Sure. So talking about the researcher's position, I think the researcher becomes more and more a manager of experiments. So as Ewan said in the beginning, we will automate what can be automated. And here, lab on a chip is just another tool for chemists, for biologists to conduct experiments. And the researcher more and more, I see, retract from the actual lab work, but guide experiments, plan experiments that are being conducted by autonomous systems. When it comes to medical doctors, to continue here, this also addresses the question Jackie asked previously. I don't think we should have any AI system decide on life and death, make life and death decisions here, because in the end it comes down to responsibility. If you're willing to take the responsibility, then that's fine, but it should not be the decision of the algorithm per se.
Yeah, if I may, I think I'd like to think that these systems will actually amplify the role of doctors, so more than replace them or whatever. So.
I like that. Arlindo. So I'll give you 10 seconds, and Jackie's going to take over.
I'm so sorry. Well, I'd just like to cite my great colleague, a radiologist, Declan O'Regan, and he said there's going to be two types of radiologists in the future: the radiologists that use deep learning tools and retired radiologists.
Fair enough. All right, that's a perfect 10-second segue. Jackie, over to you.
So another audience question is, do the panel know of examples of countries or healthcare systems where they really have achieved the right balance between access to healthcare data for innovation whilst maintaining patient privacy? Are there lessons we can learn from those particular systems? Is Ewan got his hand up?
I'm sorry. Let me just channel my inner love of Denmark. I just, if there's any Danish people watching, my God, it's done well there. Now, I think what is important in Denmark, just channeling my inner Dane, is that there is a lot of trust in the system because of the oversight, because of the work of clinicians in Denmark, and then also because of legislation that goes through the Danish Parliament. And so some of the very big decisions are debated in the open, in Parliament, and come up with rules there. So I do think the Danish system is remarkable, shows what can be done. But what I've also learned from this is that you can't just transplant Denmark and even over the border. They share a border with Germany, and yet some of the cultural starting points for this are at such different places. So it is a conversation that happens inside of each country in a political and social way. And I think we can be inspired in countries by what other people do and how other societies have organized themselves. But we shouldn't kid ourselves that there's kind of a best way. There's only ever the Danish way, the British way, the French way, the American way, the Canadian way of doing these things. And the question is what do you do inside of that system to make that system work?
Okay. Anybody else want to comment on that? Or shall we let Ewan's love of Denmark take the day?
I love it.
Sorry?
I could chime in. I'm located in Singapore, and I've been in this wonderful small country since January. And we're working on future health technologies, among other things. And what surprised me most when in light of our discussion here, what surprised me most is the readiness and willingness of so many across the society to share data. I have not encountered these harsh discussions and debates on the privacy of data. I mean, if we want to share, you share, but the readiness, the willingness seems to be much higher also in Singapore, similar maybe to Denmark, as you alluded to.
May I add to this? I think in Europe, I mean, this is hard to generalize, but I think in Europe we certainly have a deeper worry with the matters of privacy than you can see in almost all of Asia and even in the United States. This is not necessarily bad. I mean, it shows worries with privacy but I think it's somewhat also on the way. I mean, I have some personal knowledge of companies that work in this area, and they face a much harder time here than a company in California or in China or in Singapore would face. So I think we have to live with this, but we have to, I mean, this is a trade-off, right? I mean, you can have more privacy, more warranties and, GDPR and stuff, but you pay something for that. I mean, and what you pay is harder to develop new technologies. I mean, I know the defenders, people that support and defend the GDPR, will say no, but I think we have to face, there is a trade-off here.
Yeah, what amazes me is the amount of data I know I share and others on their mobile phone. And if people really understood what that could be used for, they might be perhaps less worried about the sharing of data under a more controlled environment. Chris, do you want to take over and some of those other questions?
I did have one question to ask everyone on the panel, and that is, if you step out to 2040 and you look backwards, what was the one thing that you would say happened to unlock the potential of your research domain? What was the one thing that happened, maybe say it's between 2020 and 2030 that happened? Say, this is what happened. Gisbert, you've got your hand up, and then Ewan.
I still have my hand up, so.
You go, my friend.
I can answer this question. The next pandemic.
The next pandemic happened. Okay, that's good. Not good, but okay, that's a good one. Ewan, you're next on my screen.
Okay. Well, I think it's the next pandemic, but also taking up the opportunities. We just have an opportunity of making our populations that much healthier. And again, I was saying that some of the future is with us now, and the road here that the UK has walked down genomics, I think every country needs to walk down that road.
Okay, so I'm sorry, Ewan, it's a little too generic. Say the opportunity was taken. All right, come on.
All right, the opportunity is taken in one place. We need to take it in many other places.
What happened? Like the pandemics, I could say the genomic test cost 25 cents and they were done. Everyone had the genomic test at birth, something like that. So Tim, you're next.
Sorry, I had to unmute there. It's not as fancy, but I think it's the increased distribution of information. I think we're going to see that accelerate and continue.
All right, information acceleration. Arlindo?
Your question is for the next decade, right?
For the next decade. You're in 2040 and you're still looking back and you say by 2030, this happened.
Okay, so this is a very hopeful response. It may not happen, but if you look at the machine learning systems that are supporting AI these days, they basically just do one thing. They associate a value with an input, right? That's all they do. They don't think, they don't reason, they don't consider counterfactuals, they cannot imagine scenarios and so on. They do this very well. And it's overly impressive, but they are still very, very limited. I mean, we are still having a hard time making these systems drive a car because, they can only think in very simple terms, right? In this situation, I turn right. They cannot say, what if I turn left? So I hope, or at least I don't say I expect, but maybe there will be some breakthrough in machine learning research that will move us from this simple association between input and output to some more sophisticated reasoning somewhere. And this will be a breakthrough. It may not happen in the next 10 years. Maybe it will take 20, but
Okay, Annika, you're next. Are you there?
I am, and I apologize. Somewhat ironically, I'm having technical difficulties, but I think that for brain-computer interface, some of the breakthroughs might happen actually in the lab. Looking at some of the technologies that are coming, that particularly DARPA is sponsoring in minimally invasive brain-computer
specifically? What happens?
So I think there will be a breakthrough that sort of bridges the gap between a helmet that broadly measures EEG signals, and then a implanted chip in the brain. There's going to be something in between the two of those that engenders more public trust.
Got it. Okay, I think Gordon, and then Tim, did I already ask you?
Yeah.
Okay, then Jackie, it's back to you.
Okay.
What I've been dreaming about having robot next to people, right? Working side by side people, right? Not replacing. I like the amplification analogy. It should be helping, and because there is a shortage of labor. If I talk to the industry, they are telling me there is a shortage of labor. So working side by side will be perfect.
All right, that's great. Thank you. Jackie?
Yeah, and there's a number of questions in the chat that are talking about things like hacking and, kind of the potential for human harm. What's the one thing that you're really scared of? What will keep you awake at night in terms of blocking technology development? Is it regulation? Is there some sort of, I don't know.
A really nasty virus, like 10 times worse than the SARS-CoV-2, will be very bad, I think so.
No, I'm thinking more about the application. An example would be like what happened with genetic modification of food. They had there was the guy in Scotland who said that altering the potato genome had terrible consequences and made rats very sick when they were fed genomic modification of potato. I mean, is there something in there around that you are worried about that could really stifle progress? Tim?
So your question is a technological development that will stop progress, or a side effect?
It could be so. For example, you could in the same way we did touch on GDPR, but is there some regulation that would stop the progress? I mean, there's a lot of talk in the chat about should we be regulating AI, or.
Well, I think over-regulation of AI may make the process harder. It will not stop it because it will still happen somewhere. But if you over-regulate everything because of worries of the consequences, that may certainly hinder the progress in some places at least.
I think, related to the idea of the increase, a distribution of information, that will continue, it will accelerate. And so fear, at least for me, is access to that information. The knowledge on how to access information, even if you're not supposed to have access to it, that is distributing faster as well. So the idea of hacking and cybersecurity is a big concern, just with a limited focus even on just genetic information. On the VR side, much lower risk or concern for me, but there is increasing thought about addiction, completely immersed in a separate world. I mean, if you're doing good things for other people, feel good, and is that such a bad thing? Well, there could be some negative repercussions.
Okay, thanks. Gordon, then Gisbert. Gordon.
Sorry. I still think that we're going to face a difficulty with too much information. How do you make sense of information? And that is being neglected. Right? And the whole entire deep learning paradigm is just data in, data out. Right? And association is one thing, but explainable AI is still, we're getting close, but we're far off. We need that, right? And then I think Chris brought it up, the trust. If the AI engine can actually explain to me why, then that's another level of trust. And that's something to be concerned about.
So the organizers have given us just a few more extra minutes. We've been granted because it's just been so interesting. So we're going to take that. And Gisbert, you had your hand up.
Yeah, what keeps me up at night sometimes it's the fear of success. Because imagine everything comes to pass, which we just outlined and which we speculated about. Then we're creating additional layers of dependencies where we're losing independence as individuals.
Interesting.
That's a good one to make you pause for a moment. What if all of us are successful? What does our world look like? What does society look like? Because each one of you are working very hard to reset what we understand as normal, right? And what if that really happens? What does that society look like? Okay. And that's an interesting question for us all to ask. As we're looking at the key technologies for the future, we also have to have a bit of a thought about what that future might look like.
Yeah, that's important.
Let me add, I was trying to think of a better answer to the question, which is, and is related with the information, which is the scientific information that is being published these days, every day, every week in specific fields is so large that is almost impossible for anyone or for any group of researchers to actually keep up speed and then know everything that is going on in its own field. So this may actually become unmanageable, right? I mean, there is no way you can follow the advance, and maybe you'll try to gather AI systems to do this, right? To provide you reports of what's important, what not is important, and so on. But this assumes that you can actually get to that level before you are lost in the information. So I think the explosion of information, reliable, unreliable, true, false, and so on, is actually a challenge. I think science is being faced with the challenge of processing information and separating the good from the bad. And I think this is an important issue. I mean, I'm worried about this.
That's a great one. Jackie?
No, I think we've covered most of it. Chris, do you want to sum up here in terms of?
Thank you. I'd love to, actually. Thank you. That's really great. First of all, I want to thank all of you for what was a few moments quite exciting and a few moments a bit sort of disturbing. I'm trying to imagine a robot with a skin with 5 million receptors there. I'm thinking Blade Runner came into my mind. I'm going, oh man, there you go. But it's really quite amazing. So all of you had a very common theme of AI, that this is going to be part of our lives, and try to understand how it's going to be impacting us, whether it's at the size of our bodies, all the way down to our genomes understanding. But one thing is very clear, is change is constant, and that all of us are part of being change makers. And the key thing on how we can continue to address that change, and especially, as you said, with dialogue with society. And I can't remember who said it, but I think this is a really key thing for us. It's not dialogue at society, but it's a dialogue with society. And this is a slow evolution, which is all important for us. And then everything that can be automated will be. This is something which is proven true over time. Innovation has always tried to get rid of inconvenience, and however we understand that in our lives. And so you also described some things which you saw as points of inconvenience, which was either the lack of part of our body or the dangerous work, but how can we eliminate inconvenience? I think this is something which really struck me, and I also liked very much how you were saying our goal is to amplify the human potential, to really work with. And I think this is something to take away when we're looking at these key technologies for the future, is how these can be technologies that are working with the best of humanity and the best of how we can be in our best selves. So I want to thank you very, very much for making the time to be with us today, and for all those who were online, to thank you for tuning in, and to the Royal Academy and CESAER for making this possible. And Jackie, you're a wonderful co-hostess. It was really wonderful to work with you, and thank you for opening. And with that, I will say goodbye, and back over to the organizers.
Thank you
very much. Thank you.
Thank you. Bye.
Bye.
Welcome back, everyone. Hope you had some time to get them refreshed. We're now going to go and begin our second session. This one's all about a safe, secure, and equitable society. Before we start the session, let's go to another poll, just to get an idea of what you, the audience, think in general of artificial intelligence and how it might look in 2050. So the poll is going to be coming up on your screen in a moment or so. So have a think about how you'd answer it as I make the introductions for the next session. Just to sort of give you a heads up, the questions are going to be, the question is, by 2050, do you think that general artificial intelligence will be still a pipe dream, or B, embedded in everyday life, C, a radical destabilizing force in the world, or D, our benevolent ruler? All hail general artificial intelligence. Let's see how you guys respond to that. Now, while you're thinking about that, let me introduce the next section. So shortly after the year 2000, the US National Academy of Engineering compiled two lists. One list of the greatest engineering achievements of the 20th century, and another list of the greatest engineering challenges of the 21st century. It was only when you read the two lists side by side that you realized how many of the engineering challenges of the 21st century were actually caused by the engineering achievements of the 20th century. And this comes to mind when we look at the next session. Disruptive technologies are, at the same time, the greatest threat to safety and security, and also our strongest hope in countering any potential threats and building something of a society that's more equitable. So before we go into the session itself, let me go into the poll results. I asked you, by 2050, do you think that general artificial intelligence will be still a pipe dream, embedded in everyday life, or a radical destabilizing force, or a benevolent ruler? And here's what you said. You have said, as I might have expected for this very optimistic audience, by 2015, 53% of you think it's going to be embedded in everyday life. 19% of you think it's going to be a radical destabilizing force. 13%, a bit more realistic, 13% of you think it's going to be a pipe dream, and 13% think it's going to become our benevolent ruler. So quite a range of things there, but 56% of you, optimistic as usual for an engineering-led audience, you think it's going to be embedded in everyday life, and it's probably the right way of thinking about it. So it appears our relationship with AI is complicated, however. Here to tease this out more is the next session chair, Professor Dimitri Simonidou. Dimitra is a fellow of the Royal Academy of Engineering and head of the Bristol Digital Futures Institute. So with all of that, let me hand over to Dimitra. Over to you.
And what a great introduction. So good afternoon, everybody. It is really a great pleasure to introduce this session, where, as you already heard, we are going to discuss key technologies, but also emerging thinking for a safe, secure, and equitable society in the next 30 years. I will be chairing the session with Professor Tariq Durrani, who is a professor of signal processing at the University of Strathclyde and also a Royal Academy of Engineering fellow. Tariq will facilitate the panel discussion at the end of our session. So our speakers in this session, and hopefully you are going to be able to open questions on how technologies will drive better futures, addressing key societal challenges around ethics, inequalities, resilience, but also anticipating disruption through emerging technologies such as quantum computing. And we have 4 extremely distinguished speakers in this session, addressing topics ranging from AI, ethics and regulation to quantum computing and the role of engineering in achieving the United Nations Sustainable Goals. And without any delay, I would like to introduce our first speaker, Professor Dame Wendy Hall. Among other things, Wendy is a fellow of the Royal Society and the Royal Academy of Engineering. She is a Regius Professor of Computer Science and an Executive Director of the Web Science Institute at the University of Southampton. Dame Wendy was also the co-chair of the UK government's AI review, and she is the first skills champion for AI in the UK. In May 2020, she was appointed chair of the Ada Lovelace Institute. Wendy is going to discuss how our approach to AI ethics now will shape our AI futures. So Wendy, the floor is yours.
Thank you so much, Dimitri. Thank you to the Royal Academy and to CESAER, and it's been great fun working with Dimitri and Tarek on organising this panel, and somehow I got volunteered to talk. So here we are. Are my slides up? Do I do next? Oh, yes, I can see them. They're very small. Hope you can see. Can you see my slides, people?
Yeah.
Good. All right. So, I've often called talks like this AI through the looking glass. I haven't got time to go into detail, but basically it's Alice through the looking glass I'm thinking about. And when I started off working on the web, Alice was in Wonderland, and the documents were things that people dismissed as not being important. We could toss them away. We're just waiting. The web is just about documents. But now we're going through the looking glass, where in fact things are not what they appear. Things and in through the looking glass, Alice is just a pawn and maybe a figment of someone's imagination. And I think this paints the story of how we've gone through the last 30 years. But that's working very fast actually. It went too far. We've got these clickers. It's really good technology, but you get used to them. So this picks up very much from the introduction, a brief history of AI, because we were talking about, what are we at general AI? Where are we? Well, we started with AI has been around a long time. We Brits like to claim it started with Alan Turing in the 50s. Of course, it's much more than that, but I often, that's 70 years ago, and when he wrote his paper. And if you think, if we look forward 70 years, which we clearly can't do, we will have another journey through AI. We are not done yet in terms of AI frontiers. We've gone through the expert system phase and the neural network phase, and between these we tend to have AI winters, and I haven't got time to go into all that, but we're now at the machine learning, deep learning phase, and that will not on its own get us to artificial and general intelligence, which is the last picture there, the science fiction idea that we might have systems that are cleverer than us, which might, as Stephen Hawking said, out-evolve us. But there will be more breakthroughs in the future, and it is controversial as to whether we can ever have systems that think like human beings, or as better than, or as well as human beings. But my point in this talk is that if we don't start thinking about that now in the way that we regulate AI, think about the ethics, if we do get to that point, then it's, without having thought about the AI, the ethics and the regulation, it's too late. So we need to think about it now, whilst the scientists and the boffins and the young person in the lab today is having the bright idea that in 30, 40 years time will be the next breakthrough. So that's my starting point. And why AI now? The AI we have now, the machine learning, deep learning, we've been thinking about these, as my slide before said, for since the 70s and 80s easily. So 30, 40 years, these ideas have been in the laboratory and scientists have been thinking about them. But we are here today, we have AI so dominant today because of two things: the amount of data that's available, and that's largely happened because of the ability of the internet giving us, and the web giving us the ability to create and share that data. And then the huge power of computing that we have today to analyze it. So that the things people talked about 30, 40 years ago that you couldn't actually achieve, we can do today. We can train machines on lots of data, supervised or unsupervised, to come up with answers to questions. But what the answers are and how they do that is really important to us. So the opportunities is this where we have to practice. There are lots of opportunities, and I don't want to, the health. I mean, that's been so much in COVID, how we can use AI and the data we generate about the vaccines and our reactions to them and where the cases are, and nationally and internationally. AI and every aspect of health, AI is going to change. There are huge opportunities in transport and in education and in energy supply and food and retailing and issues of digital twin and the new ideas of cyber physical fabric linking sensors to the digital world, to the physical world. And there are going to be amazing opportunities for AI that are going to, and they can help us solve, it can help us. And that was a very important point. The things we're trying to solve today, like climate change, largely engineers and scientists created the wonderful systems that have led us to be able to travel and burn energy like we do. And we have a responsibility as scientists to make sure we're leaving a better legacy for future generations with our inventions and the way we deal with what's happened in the past. So in terms of, sorry, I can't read the slides on the screen. I have to get my own version up. So as Dimitri said, I co-chaired the AI review for the government in 2017, and that led to the development of the AI Council, which I'm a member of, and the Office for AI in government. And the AI Council published its a new roadmap earlier this year, and saying to the government, we'd made some investment over the last 4 years, but actually that's just the beginning. We've got to double down on that, and we have to look forward the next 3 or 4 years and see how we should keep on accelerating in the way that we develop AI, create a skilled workforce, and make sure we do this so it's for the good of humanity and doesn't do us more harm. We published our roadmap, and the 4 pillars of the roadmap were research, development, innovation, skills and diversity, data infrastructure and public trust, and national cross-sector adoption. Now, I haven't got time to talk about all those today. I'm going to talk largely about skills and diversity. We have funded a number of, over the last 3 or 4 years, we've funded the increase in PhDs and master's level courses and fellowships, and we need to do more of that. But of course, for every MSc and PhD student you fund, you need a professor to supervise them. It takes a long time to grow an AI professor. So we have to keep on pushing and recruiting and retaining the talent. But now we've got to move beyond that and actually get AI into education generally, schools, apprenticeships, further education, AI and data literacy for everyone. You'll see that coming out in the new AI strategy as it emerges later in the year. And the big thing for me in all this has been diversity. And we actually, because we were seeing the way we were putting the programme out, that we were going to increase the lack of diversity in AI by funding PhDs and master's programs that were taking from a very narrow pipeline. We actually funded a program of MSc conversion courses that took people from non-STEM subjects, that take people from non-STEM subjects and get them ready to or educate them, make them aware of AI. And 50% of the scholarships that were funded in that had to be for underrepresented groups, so for women, people of colour and people with disabilities. And I'm giving a talk on that next week at the Westminster Forum. The results have been fantastic. They've been picked up and we're spreading the diversity. I'm going to talk a bit more about diversity in a minute. But all this leads to the fact that we're talking here about, sorry, I'm going too fast because I'm right. Something that you can call it socially responsible AI or human-centered AI, that this is not just about technology, it's about how people use that technology and what impact the technology has on people. And this idea that these systems are often, we have people and technology working together to do things. And we've got to take account of that human in the loop. There's stories all the time. There was one today about how Amazon decides which employees to let go depending on an AI system that it doesn't seem necessary to be fair. And there are stories all over the place. And we know when things go wrong because we've seen the Cambridge Analytica story. We've seen the when cars start to kill people. Well, cars kill people all the time, but a car without a driver kills someone is a big deal, and we need to worry about these. The Microsoft, sorry, I paused because I have to wait for the next thing to come up. It's a slight delay. The Microsoft bot that was turned into a Hitler-loving sex robot within 24 hours because people could. And the designers didn't think about the fact that that might happen. And then, of course, the whole, the deep fakes that's emerging, which is a scandal in terms of, if you use someone else, that's not Mark Zuckerberg. And there's plenty of examples of this around. And anyway, I can't remember. How long have I had, Dimitri? I like to think that there's a wonderful film, if you haven't seen it, it's available on Netflix now, which was really the example of explaining coded bias, the film is called, and Jo Boitalama, the story of her, she's in it, her PhD, about how she when she was doing her PhD, she realised that the vision systems did not detect her face because she is black. And they detected faces much better if they were white, and that got her onto this journey. And I'd recommend that to you if you haven't seen it. So we are in the UK quite awash with AI and ethics research groups and centres. The Centre for Data Ethics and Innovation, the Leverhulme Centre, the Ada Lovelace Institute that I chair, and the next speaker is the director of Digital Ethics Lab at Oxford, the Alan Turing Institute, the Digital Catapult, the work that's going on in Oxford in the humanities and AI and ethics. And so we are beginning to look at this very seriously, and countries are beginning to look at it. We have a number of national strategies that. So this is the House of Lords report, AI ready, willing, and able. In the UK, we're still working out how to regulate in the UK in this area. This is the original call from the EU, and about AI's got to be about ethics. And then there's the even in China, we have the Beijing ethical principles. And in fact, just recently, and I was talking about this with Carly this morning, the EU produced a draft set of regulations that we've all got to study and see how it might affect us and how we work with it. We're going to see more and more of this, and it's incredibly complicated, and how we work it out on a national and an international level is going to take up a lot of very big brains and deep conversations over the next few years. Industry, obviously, I've got to finish, right? Industry obviously is looking at this.
Carry on.
All right, I just finished. I'm nearly at the end. Industry is beginning to look at this, setting up ethics boards, Google. And the big thing about this set of slides is that Mark Zuckerberg was saying to the government, you've got to help us with this. We can't deal with all the problems. And then we've got our online safety proposal from our government, which is really saying, actually, no, you've got to be worrying about what's on your system, and there's a sort of backwards and forwards about who's going to be responsible and who's going to decide what's a hate crime, what is hateful, who makes those decisions. Do we really want commercial companies to be doing that? So we've got the online safety, yeah, I haven't got time. So I just want to finish with the point that diversity is so important in here. My mentor, Karen Spark-Jones, used to say, computing's too important to be left to men. And that's not to denigrate men. It's to say we're all in this, and women need to be involved as much as men. And I would say it's so important for AI that we have, because bias can be in data and in algorithms. It's, oh gosh, I've lost my button. And so it's so important. I just want to get to my last slide. We need interdisciplinary teams and need to insist on them. And this is my last slide, which is we've got to tackle all these things from a socio-technical perspective. We can't just leave the technologists and the programmers to do it for themselves. We have to have human-centered AI. Diversity should be in any ethical framework. In other words, if it's not diverse, then it's not ethical or it's unethical. That's my final point. Sorry if I overran.
No, Wendy, that was perfect timing, and thank you very much for the inspiring talk. It is now my great pleasure to introduce our next speaker, Dr. Carly Kind. Carly is the director of the Adler-Lovas Institute. She is a human rights lawyer and an expert in technology policy. She has advised industry, government, and non-profit organizations and has worked with the European Commission over the years, the Council of Europe, numerous UN bodies, and also a range of civil society organizations. Today, Carly is going to introduce the Technologies Regulatory Agency. So, Carly, over to you. We are looking forward to your talk.
Thank you, Dimitra, and thank you for the promotion and honorary doctorate. I'm not a doctor, unfortunately, and of course I am here with all of these very eminent scholars, so thank you for including me in this panel. My name is Carly Kind. I'm the director of the Ada Lovelace Institute, of which Wendy is our chair, and she kindly introduced us. We are a UK-based research institute and deliberative body with the remit to ensure that data and AI work for people and society. And that means we care about the ethical and societal questions which arise with new technologies such as AI. I wanted to involve you all in a thought experiment today, whereby I talk you through what might happen if the UK government set up a new regulator for technologies. And I was really responding to the prompt around what would a safe, secure and equitable society look like in 30 years. So if we take ourselves forward to 2050, what infrastructure exists in order to ensure safety and equity when it comes to new technologies? And in my opinion, the direction of travel is around more regulation in this space, as Wendy highlighted. And so I thought it might be useful for us to cast ourselves forward 30 years and look at one potential model that might be in place and ask ourselves what might be the impact of having this type of regulation when it comes to AI. So I have conceptualized this thing called the TRA, the Technologies Regulatory Agency. And I will speak from the perspective of the director of that agency. So we established the Technologies Regulatory Agency in the early 2020s, responding to the wave of AI regulation, which was spreading across Europe, but also, as Wendy said, China, which plans to adopt AI regulation by 2025. And it was really off the back of growing recognition about the risks of AI technologies and algorithmic systems being deployed across the world. In the UK, the most high-profile one in 2020 having been the use of an algorithmic system to decide A-level results by Ofqual, which caused quite a lot of public backlash, and many of you will remember the student protest at the time. And at that time, the UK government decided to put in place a strong regulatory regime in response with its 2021 AI strategy and modelled it on the US Food and Drug Administration and called it the Technologies Regulatory Agency. So how does the TRA work? The TRA works in three major functions. It sets standards through regulation. So it has the power to issue regulations and guidance about how technologies should be designed, to which technical specifications, and how they should be deployed by public and private sector actors. So, for example, the TRA might have the ability to set minimum levels of uncertainty, statistical uncertainty in machine learning models used in a particular domain, such as healthcare. And all products designed in that space would have to comply with that regulation in order to be released onto the market. The TRA also certifies products. So when certain products which are high risk want to go to market, they require TRA pre-certification, so a license essentially, in order to be able to go to market. and the TRA will list which categories of products fall into these classes. So, for example, the TRA might require that an AI product being used in the delivery of public services requires pre-market approval. And it also receives and investigates complaints. So members of the public can go to the TRA to complain about when they think an AI system is in non-compliance with the regulations that the TRA has issued. And it can issue product recalls. So just as we know well in the medical space, for example, the TRA can require that companies withdraw a product from the market. In terms of how the TRA considers different types of technologies, it would be classifying AI products into one of three classes. And this is modeled on the current US FDA approach to regulating technology in the medical space. So they consider class 1 products to be those which pose a low risk to individuals and society. And developers, researchers, companies that are wanting to sell those types of products must, at the very least, register their establishment and list their product with the TRA. So at the base level, we have a national register of all AI products which are currently in deployment. The second class up from that would be AI products which pose a moderate risk to individuals and to society. And in that case, developers must make a pre-market notification to the TRA, which means that they are telling the TRA they want to sell a new AI product, but that it is substantially equivalent to another device that's already legally on the market. And if it's not, they have to go through a process of establishing that it complies with TRA rules. The third class of products are high-risk AI products, and there we might think about products in the healthcare industry or in the law enforcement, in justice sector, for example. And in that case, developers would have to subject their AI system to randomized control trials and bring the evidence of RCTs to the regulator in order to get their product certified that it can go to market. So what has been the positive impact of establishing this particular regulatory body? So we've seen that on innovation, those products which are already equivalent to products on the market are able to be approved pretty swiftly. So if your product is the same AI product that's already out there or substantially equivalent, you can move to sell it relatively quickly. We've seen that RCTs are more commonplace in the tech development process. That means that they're more robust, they're better tested, less likely to be faulty or dodgy AI products being deployed on the public. And there's more harmonization on technical standards. So there's greater security, for example, rather than kind of badly designed products from a security perspective being taken to market. The impact on accountability and compliance has been considerable. We see developers of AI technologies more in the public domain. People are able to scrutinize who's selling AI systems and have roots of accountability and liability back to those people, those developers. There's very little fraud or non-compliance in the market as a result. And we no longer see companies testing new products on the public, but rather only bringing out new products when they've already been tested. And the biggest upside has been immense increase in public trust in AI. So we've seen people across the board feeling much more comfortable with using AI in government, in the justice system, in education sector, in the assessment of school results, for example, because they can see the important role that the regulator is playing. And they also see issuing of large fines and enforcement taking place very often. So what negative impact has this type of regulatory authority had? So on innovation, it takes between 1 to 2 years to give a product, a novel product, pre-market approval. So that means the time between AI products being developed and going to market there's a substantial lag there. The requirement to undertake RCTs for novel AI products again slows down the research phase. So the time between which AI products are in research versus rollout to market is much longer. And as a result, the threshold for smaller companies to take AI and automation products to market is much higher than it is for bigger companies. So we see a concentration of AI innovation in the hands of larger companies who are better able to navigate the regulatory system. And so the TRA might be said to have had a negative impact on market competitiveness because it has resulted in the further consolidation of AI research in fewer companies. As a result, and again, this is modelled on the FDA, there's been attempts to try to overcome this by pre-certifying certain companies so that they can take their products to market quicker. But on the other hand, this tends to prioritise incumbent companies. So the companies which are best able to get pre-certification are those big companies like Apple or Google, who are able again to negotiate the regulatory environment. So that's the end of our thought experiment. I think it's useful to think about how a quite a comprehensive regulatory approach would impact both negatively and positively on research of new technologies. And it's important to state that although this seems quite fanciful, it's very much more comprehensive than we currently have in the UK. It is not so far from where the direction of travel is heading. As Wendy said, the AI regulation has just been published by the EU in draft form, and they similarly class products as low risk and high risk in that same way. What they don't have in the regulation is pre-approval by a regulator. So the compliance with the regulation at this stage is based on self-assessment of conformity with the regulation. And I think that's going to be one of the big battle areas going forward about whether or not self-regulation works or whether or not you need an empowered regulator to pre-certify products before they go to market. But I think it's really interesting for us to keep track of that and to keep looking at what's happening also in the UK with the draft AI strategy, which, as Wendy said, will be published later this year, and what's happening in China, where they have also said that they want a comprehensive framework for AI regulation by 2025. So AI regulation is here. It may not take the form that I've just talked you through today, but that is one model that is in existence that we can look to. And I think it will be interesting for us to discuss how that might change the system going forward. Thanks very much.
Thank you very much, Carly. And we have to move on to our next speaker. So our next speaker is Professor Dominic O'Brien. Dominic is a professor of engineering science at Oxford and the director of the UK National Hub in Quantum Computing and Simulation. He was previously co-director for system integration of the NKIT Hub and a member of the Placket Review of Quantum Technologies. Dominic's own research is focusing on optical wireless communications and particularly on system demonstrations with a number of world firsts in this area. Today, Dominic is going to discuss the future of quantum computing. Dominic, you may start your presentation.
Thank you very much. So thanks very much for the introduction. My name is Dominic O'Brien, and as it said, I'm the director of the Hub in Quantum Computing and Simulation. I'm hoping to give a very brief introduction to quantum computing, then talk about some of the impacts that I think it will have over the next 30 years. So just to mention, the UK, in common with other nations, has a very vibrant national quantum technologies programme. This slide shows you some activity. There's a network of research hubs, of which I direct one of them. There's a National Centre for Quantum Computing. You can see the artist's impression of the building on the right. And there's a lot of industrial activity. It really is a growth sector, both in the UK and globally. But how did we get here? So you can call the quantum revolution really in sort of two phases. From the 1900s to the 1990s, we started with an understanding of quantum mechanics. And then a whole raft of devices were developed using quantum effects. And this is what people call quantum 1.0. So things like the silicon chip, LEDs, lasers, and really those devices have been at the heart of the information revolution. Those have really transformed our lives over the past 5 decades since the chip was invented, really. in the early 90s, really through to the current day, people started to harness what people call quantum 2.0 effects. And these are really the quantum effects you only see at the atomic level. So the ones that people understand maybe or are superposition, that's the Schrodinger's cat in the box experiment. And entanglement, this is what Einstein called spooky action at a distance. Entanglement is this way that one particle can interact with another at a distance. So by changing one, you change some aspect of the other. And these are the two effects, these quantum 2.0 so-called effects, that you can imagine with the rate of progress at the moment by the 2050s, that these capabilities will be routinely deployed in a number of areas. Computing really is just one of them, and that's the area that I'll focus on in this talk. So why is quantum computing different? Now, I have a very limited amount of time, but I just want to give us a quick snapshot of why it might be different. So on the left-hand side of this diagram, you see a conventional bit, and that can either be a 1 or a 0. So let's imagine a 2-bit number, 10, and that means 1 lot of 2 to the 1, marked in red on your diagram, and no lots of 2 to the 0, marked in red on your diagram. The red things are called bases. And effectively, the more bases you have, the richer an information space your computer can have. So for n bits, if you get n bases, 2 bits give you 2 bases, and so on. Now, because of these quantum 2.0 effects with quantum bits, they can be 1 and 0 simultaneously. So looking at our 2-qubit number, we end up with 4 bases, and they're listed there. So 0, 0, 0, 1, 1, 0, 1, 1, if you will. And the interesting thing is any mix of these can exist together. So you imagine you grow this enormous information space as your number of qubits grows. So for n qubits, you get 2 to the n bases. And it's this exponential growth in the information space, if you can process the information, that gives you the quantum computer a sort of fundamentally different scaling law. Well, where's that take you? Just a little snapshot. So how many qubits for beating a classical computer? So the limit of what you can simulate properly on a classical computer might be 45 qubits, it might be 50, it might be 53, or some number around that. But it's around that sort of scale. And these are the largest computers in the world, consuming tens of megawatts of power, really very large machines. So once you build a quantum computer with ideal qubits in even 50 to 100 qubit range, you can outperform classical computers for some tasks. Things like the one that people talk about a lot is code breaking. So by 2050, it's quite likely that we will have re-engineered our digital security system to both include some quantum communications, some which can have intrinsic security, and also a re-engineering of our normal digital encryption systems as well. So that's the promise, if you will. But this is early days. So how do you build them? Now, this is a really interesting question for an engineer that there's no one answer at the moment. So each of these technologies you see here are competitors, if you like, in being the one that becomes the lead. So superconducting qubits and ions are quite mature. There's work in semiconductor-based qubits, in diamond, qubits using light. So there's a whole range of things which might be the technology of the future. In 30 years' time, it may have come down to one. We really don't know at this stage. So where too far. So where are we on this evolution? Well, we're in the 2020s, and we're in what they call the noisy intermediate scale quantum era. So we have a number of noisy qubits, and the noise, as you do calculations, builds up and renders those calculations eventually meaningless because the noise dominates. And we don't have many qubits. So we're in a learning phase, but there's very rapid technological development with very large scale investment globally in this area. We'll reach this middle point, which people call quantum advantage. And that's where for specific tasks, a quantum computer can outperform a classical machine. And areas which show promise for this are things like materials design, molecular simulation, problems which are intrinsically quantum in their nature. Now, as we move on to the 2050s, given the rate of progress at the moment, we're going to have large-scale reliable machines, smaller quantum co-processors, which will work with normal silicon machines, and a quantum internet. And that will be a connected network of quantum processors doing both secure communications and support secure computing and many other things as well. So we'll see this really deploy on a large scale, I imagine, given we've got 3 decades to go, as it were. What might you use it for then? It becomes a much more general tool, logistics and planning. AI has been mentioned a lot, optimization, engineering design, drug discovery, finance. It'll be another arm of high performance computing, but with different sorts of power and different sorts of scaling for a subset of problems, I think.
You've been muted, Dominic.
Dominic, you're muted.
Sorry about that. So where do I consider the impact? In health and well-being, there'll be the potential for new diagnostics and informed decision-making, new treatments, molecules developed using quantum computing. There'll be a new economy. There'll be new industries in materials and chemistry. The understanding that a quantum computer might bring might give us new processes, much more efficient processes. Finance, more efficient financial trading, risk modeling. In terms of security and stability, I haven't had much of a chance to talk about other quantum technologies, but those can contribute to a robust and secure infrastructure. Of course, we have to recall there is this risk around encryption that is actually being addressed at the moment. And the solutions are sort of quantum and sort of digital, but together you can see it contributing positively to a robust and secure infrastructure. Better predictive ICT, things like climate modeling, we're just starting to see activities in that area. And for the life of the citizen, more efficient decision making with increasingly urban populations, the sort of smart city concept and the ability to make local decisions rapidly need these sorts of computing power. Energy efficient design, new battery technologies, a whole range of things. Just as computing is embedded in our world at some level, at the moment, we will have a different sort of computing power available, I think.
Sorry, Dominic,
it is, where do I think the planning and action should be? And it's very interesting that many of the themes have been mentioned by previous speakers. So in the universities, we need to be training the people who are going to train the people, if you like. We need to make sure we invest in future academics and those sorts of things. Universities have been a real source of innovation and new spin-outs so far in the world of quantum technology, and the sort of custodianship of intellectual property and ideas, I think, is very important. And also they're really the home of, as we saw in the list from the last talk, Dame Wendy's talk, they're the home of a lot of work on policy ethics and regulation. So I think it's important that that's recognised as being very valuable for our researchers. Again, this is a message that's been mentioned before. It's really about maintaining funding, the pipeline of ideas. We're really in early days here, I think. Also, I think we need to recognise that new funding, venture funding, is going to be needed to build and scale these systems. And that's going on at the moment. For government, establishing the government really as a first user and itself understanding widespread technological impact with forward-looking regulation, and it really chimes a lot with the AI thoughts that we've heard earlier, and a continuing conversation with citizens over new technology introduction. Here, I don't think it's particularly a quantum issue. It's high technology, which very few people understand, if you like, but has implications for everybody, and a broad effort to educate the community. So I'll leave it there, and I hope I can answer some questions a bit later.
Thank you, Dominic, for making quantum computing so approachable to non-experts. And thank you very much. So final speaker is Dr. Marlene Kanga. I must say that Marlene is joining us from Sydney. So thank you very much. I know that this is an exceptionally unsociable time for you. Marlene is the immediate past president of the World Federation of Engineering Organizations. That is represented some 100 engineering institutions and approximately 30 million engineers around the world. Marlene herself is a chemical engineer. She is a member of the Order of Australia, which is a national honor in recognition of her leadership in the engineering profession. She is also an honorary fellow of the Institution of Engineers in Australia and an honorary fellow of the Institution of Chemical Engineers in the UK, both in recognition of her distinguished contributions to engineering. Today, Marlene is going to discuss the role of engineering in advancing the UN Sustainable Development Goals and potential impact of such actions by 2050. So Marlene, please take the floor.
Thank you very much, Dimitra. It's a real pleasure and an honor to be here. And I'm actually struck by the alignment of the previous speakers and some of the ideas that I'm going to present here. So let's hope my clicker works. Yes. So, sorry, let's go back. So just a quick word about the World Federation of Engineering Organizations, which you've already mentioned, across 100 nations, 30 million engineers, and we represent engineering at the UN and its bodies. So we are really the international voice for engineering. And I'm hoping that my talk will present some of the perspectives, the global perspectives on the implications of technology in 2050 in some of the less developed parts of the world for a safe, equitable, and secure society. So in terms of emerging technologies, we've already heard from previous speakers on the emerging technologies. And I just wanted to say here that the exponential changes in technology, we have, of course, Moore's law and other changes with genomic sequencing and other technologies. It makes it difficult to predict what the world is going to look like in 2050. So I'm just going to focus on three changes that are going to have implications. The first is the growth in the Internet of Things and the number of devices that are going to be deployed, estimated to exceed 30 billion by just 2025, let alone 2050. And of course, these devices are going to generate large volumes of data, which will be communicated increasingly rapidly. The speeds of communication are going to increase again exponentially until 2050. And of course, as we just heard from Professor O'Brien, quantum computing technologies are going to enable analysis of large volumes of data that's generated from this Internet of Things. So just focusing on this area, let's think about the implications on the scenario and impact for the future and what the world might look like. So of course, there are huge benefits of technology in terms of the globalization of trade, making new markets and businesses possible, increasing entrepreneurship in even the most remote and regional parts of Asia and Africa. Cities will be more urbanized, of course. More than 50% of the world's population will be living in cities by 2015. And new IoT technologies and data will enable, for example, smarter cities, managing traffic, responding to emergencies, optimizing the use of energy and water, monitoring air quality, enhancing the safety of citizens, including managing pandemic outbreaks, for example, overcrowding, social distancing, mask wearing, and so on. And as the population ages, these technologies will enhance the quality of life, and wearables, both outside and inside the body will monitor our health, prevent chronic diseases, and so on. And of course, more industries will emerge, which will be increasingly personalized in services, transport, and so on. But what are the downsides? One of those, of course, is privacy, which has been mentioned in the previous session and also in this session. So privacy concerns arise around the world in terms of the increasing use of sensors and data. The new industries also enable the transfer of risk and wealth from the poorest and most vulnerable to create extreme wealth, which might be, in fact, a new form of colonialism. For example, during 2020, 5 centi-billionaires emerged in new industries, such as Amazon's Jeff Bezos, online retailing, Elon Musk in commercial space travel, Bill Gates and Larry Ellison in Microsoft and Oracle, the e-business and internet, if you like. And then, of course, Mark Zuckerberg in Facebook and social media. These are new industries and sectors that didn't exist 20 years ago, and they're expanding rapidly into new geographies. For example, Amazon is expanding into Africa through its online retailer Souk. And the new technologies are creating a new world order. Not only are the rich countries getting richer, as you see in the top left-hand corner, but we have new companies emerging. If you look at the list of companies in 1989, none of them appear in the top 20 companies in 2021. And we have the replacement of companies in automotive manufacturing, oil and gas, and in banking, replaced by the new technologies, of course, related to internet communications and social media, online retailing. And you can see at the bottom of the screen, Amazon has grown in just 15 years to 4 billion in revenues. And this globalization of technology and seamless flow removes physical boundaries, creating a new world order. You see in the top left-hand corner, I've got the spread of the Belt and Road countries going from east to west. The growth in the right in the number of graduates, exponential growth almost in China compared with a flatlining in the United States. And the growth of technology graduates is going to then have implications for us in terms of technology of the future. And most importantly, there's the battle for standards. Who is going to own the standards and therefore the products of the future? And Carly Kind talked about regulation of AI, and this is one area, but there are many other frontiers of regulation. The other major area is the increasing complexity of global issues with no boundaries, requiring, in my view, more interdisciplinary and systemic approaches for technology development, implementation, and regulation. On the left-hand side, you see the complexity of the energy transition involving so many sectors. And of course, the two big global challenges that we all are facing: climate change in the top right, and of course the pandemic, which knows no borders and which we've all dealt with in the last 18 months. Increasing cybercrime and loss of intellectual property is also on the rise as new technologies become more valuable. This has become a profitable business, but the implications are that technology advances are also creating new frontiers of deterrence. So no longer do armies go to war, but this is a new war in cyberspace. And while we think about all these challenges, we've got to think about the UN Sustainable Goals and the imperative to address inequality so technology benefits everyone and we leave no one behind. And you see here from Fiji, the simple approach for natural disaster resilience. And we as engineers need to think of how we implement these, especially in the small island developing states. We have to address the digital gender divide, which is much more extreme in developing countries in Asia and Africa. Sustainable energy, of course, as we see in darkest Africa, an unfinished business that we as engineers need to address. Water and sanitation for all, and of course, inclusive innovation that are affordable and accessible to everyone. And of course, we've got to maintain the social license for engineering. As you see here, the protests against coal seam gas exploration by farmers in Australia and young people like Greta Thunberg for action against climate change. We can't predict the future, but the basic message is we need more engineers with the right skills to implement the Sustainable Development Goals, an idea that's echoed even by the UN Secretary General about his faith in engineers solving the most pressing challenges that we face. So I suggest a new Industry 5, as it comes up in the next 20 years, a new Sustainable Development Goal to accommodate the new technologies. And I'd like to mention that the Royal Academy, in fact, came up with the idea of engineering for sustainable development in 2005, 10 years before the UN SDGs were actually taken up by the United Nations. And I think now is the time for us to start thinking about the new set of sustainable development goals for a safe, secure, and equitable society. And other things that we might think about is how engineering needs to change. We've just implemented new graduate attributes that underpin engineering education, that thinks about the role of technology and engineering for the future, so that we have a safe and secure world and leave no one behind. But we now need to think about education for 2050, the next generation, and transform engineering education, echoing what some of the speakers have already said, for more diversity in skills, for AI ethics, for looking at IT skills, and perhaps removing the discipline divide and just looking at streams of skills that engineers can then use to adapt the best the best products. And in terms of regulation, also mentioned by previous speaker, we need to be able to be agile in developing regulations across boundaries, so that the technologies that will flow across geographical boundaries will also benefit everyone. And also collaborate globally for data protection, developing new vaccines for a safer world through groups like CEPI, and importantly, protecting intellectual property through organizations like WIPO. So to conclude, we need more people with STEM skills, people studying science and mathematics, and we need more engineers to lead, to facilitate the advancement of a new world order so that no one is left behind. Thank you.
Thank you, Marlene. What a great way to close the session. A really great way. So we are going to move into the panel now, and Tariq is going to chair the panel.
Well, thank you very much, Dimitra. Thank you to our 4 excellent speakers. They kept us all on time. They were diverse, but they were still related. We've had a few questions in the chat box. So let me start off by posing these to you, and then we will open it up for further discussion. So one of the questions that is being asked is, how can mass adoption of AI technology, which will require huge amounts of energy, how should we regulate it in terms of sustainability? Who would want to take that one on? Okay. The whole question really is going back to what Marlene was saying, that if we ensure that sustainability is part and parcel of our discipline and something that we teach, then how can we ensure that this is commonly appreciated, bearing in mind that there are certain clear tensions within the curriculum to include all these emerging areas? So is somebody willing to say a little bit? I think Wendy mentioned the introduction of these new disciplines within postgraduate programs. Would you care to share that with us, Wendy?
Well, I don't know about education. I'll pick it up, and I'll just shoot from the hip. I mean, we in the UK, the government has set this very aggressive target for electric cars, but I don't think anyone's done the simulation of what demand that puts on our electricity grid. I certainly haven't seen one. And I think that means that use of technology for driving AI pales in insignificance in terms of that sort of, but that doesn't mean it's not important. Every time we click using the cloud, you think the cloud is something soft and fluffy up there. Actually, it's all bits and bytes drawing electricity from the grid. And we have got to seriously think about, it's all very well going green for supplying electricity, but the demands we're going to make, if these things come together on our electricity supply, are going to be absolutely huge. And I don't believe we're really talking about that in a holistic way. There's a lot of controversy about how much demand on the whole blockchain debate that is constant. You can't run blockchain because it will just consume all the power in the world. And then there's people that kick back and say, no, that isn't going to be the case. I don't think there are definitive answers, but it's absolutely a major discussion that engineers need to have and get some evidence for and some hard facts about.
Thank you, Wendy. Carly, would you like to come in? You're muted.
Thank you. Yeah, just building on what Wendy said, I think, the question is a really important one, because even aside from what Wendy said about the drain on the electricity supply of other forms of and other industry decarbonisation, there is, of course, a huge issue around data centre carbon footprint, and that is only going to get worse as we move to more technology in every part of our lives. The estimate I've seen says that the IT sector will make up 14% of global carbon emissions by about 2030. 2030, that can't be right. Further into the future than that, but at some stage in let's say 2050, 14%. So thinking at the moment the airline industry is 3% of global carbon emissions. So it's a considerable chunk of global carbon emissions that we're heading towards. So starting to think about that, and then I think the question is heading at the use of data and energy for training large AI models. I think the most recent research I've seen shows that training one large AI model accounts for something like the carbon output of 4 cars over their lifetime. So again, not inconsiderable. The Royal Society put out a report late last year or early this year, called Digital Technologies in the Planet. And one of the things they looked at was the carbon footprint of AI, training AI models. And they suggested a approach which they call energy proportionality, in which they say that training AI models or building AI systems should be proportionate, the energy usage should be proportionate to the benefit that system is going to bring to society. Now, that's a huge calculation that's really difficult to do. And so Wendy's point is right, which is we need good facts about the energy consumption of training AI models in order to then weigh that against potential societal benefit. But I think the question is a really important one. We're starting to see so many more people talk about this issue, actually.
Thank you. I think within the same vein, there is a question that's been put in the chat box. What do we need to do to ensure that AI helps reduce rather than entrench or increase social inequality?
Can I answer that, please, Tariq? Okay,
Marlene.
Yeah, I think it's. I was very interested in Carly's thought experiment and the regulator of the future, and that model would work in a country like the UK, where people are generally literate, well educated, and there's general equality. But you think of applying something like that in a country in Africa or Asia, where you have you don't have those levels of literacy. there are so many dangers with AI in implementing that. You have so much power in the hands of the few, and really it'll be very difficult to manage and control. And I think for the benefit of the world, one of the areas to think about is whether we collaborate globally for global regulations, because these technologies are just going to flow across boundaries very freely. They won't stop at a geographical boundary necessarily. And so we really need to think globally about regulation and about agile regulation, as the World Economic Forum has set up that group. And to think of, again, those that are most vulnerable and how we would protect them with regulation.
Thanks, Marlene. Is anybody going to pick this one up? Wendy, do you want to add something to that?
No, Carly was just putting her hand up.
Yeah, okay, Carly, go ahead.
Yeah, just to build on a little further what Wendy alluded to before about bias, I think the big challenge around in particular predictive AI models is that they essentially learn from previous historical experience, which has been one which has entrenched social inequalities. And even when your data sets are 100% correct and accurate, they may still contain societal biases. So Kate Crawford, who's written a really excellent book called The Atlas of AI, gives this example, which is if you had an entirely correct data set on every person who's ever been president of the United States, and you use that data set to train an AI model which might predict who would become president of the United States in the future, you would of course have a data set that was entirely white and male and affluent, and the predictions based thereon would be informed by those biases. So often the question of bias is people try to attempt to answer it with a question around the rigor of training data sets and accuracy in training data, but there is this persistent question around societal bias that will plague particularly predictive systems that we need to acknowledge at the outset and then start to address, as Marlene has said, through things like global regulation and collaboration as well.
Thanks, Carly. Dominic, there's a question for you. What is going to be the first major social impact of quantum technology? It's a very widespread, wide-ranging.
Yeah, I think that's a very difficult particular thing to identify. Look, I think if you took the average life of the citizen, if you look at conventional computing, that's kind of embedded in what we do. That many of decisions, navigation in our cars, whatever, there's a computer there somewhere in the background. And increasingly, that's a large computer served by high-speed communications. So I think as that computing power that's available remotely grows, if you ask yourself, well, what's that going to allow which we can't do now? I suppose it's a greater personalization of that decision making, that you'll become a category on your own rather than a broad category. Taking a sort of a trite example, the Netflix recommender algorithm gets better and better with more computing power because it can personalize. So I think you might see, on the positive side, decisions that are made automatically about you become better simply because there's more computing available in the background. And then there'll be things like better batteries, more efficient wings on aircraft, all of those really difficult design problems that really stretch high performance computing today, that as the power becomes available. So I think it's hard to identify really direct things which will be a social impact. It'll be the sort of pace of technological change will continue using a different set of technology. I think there are some, there's some particular risks around encryption and things, as I mentioned earlier, to do with quantum computing being a different way of doing the problem. And those are being addressed. And so, if we see evolution running positively, we won't see the risk associated with that so much.
Thanks, Dominic. Wendy.
Yeah, Dominic, I'd like to pick up on that a little bit and forgive my ignorance of your area. But, you said Netflix gets we get more personalized because of the compute power, but it is also, as several of us mentioned, the fact that they have access to our data, and those privacy concerns or security concerns are really important. And I'd also love, while I've got you, to ask you about what effect you think quantum will have on security on the internet, because, you know, my worry is when the bad guys get quantum computers, lots of things that we take for granted today could become destabilized.
Yeah, that's right. I mean, when I was preparing this talk, I talked to the person that runs the Quantum Communications Hub, and we thought by 2050 we wouldn't be securing communications as we did now. But just a bit of background is this is a known problem, and there are sort of two approaches to it. One is using new quantum ways of securing communications, and the second is re-engineering the digital encryption security we use at the moment. Both of those are underway. So, for instance, NIST, which is the US national standards body, has a competition running at the moment to look at the next generation of digital security, which will be called post-quantum, is the particular buzz phrase, to be quantum secure. So you're right, a known problem, but with effort to solve.
Sure, I love your optimism, though, Dominic. I hope it's as smooth as you're predicting, because I don't think it will be somehow. But
we'll need to come to an end now because our witching hour is approaching. So it's very difficult to really summarize the presentations that have been made. First of all, on behalf of Dimitra and myself, we are very grateful for you to share your wisdom and your expertise, and more importantly, your time, to give us a view of what you see is the vision and indeed the path towards a safe, secure, and equitable society in 30 years. Dame Wendy shared with us the future world of AI. It was interesting to note that she was very optimistic about the future, something that was really shared by all the panelists over here. So we are looking for that. Having said that, she did point out some of the hazards and pitfalls, and these were very neatly taken up by Carly, who talked about this new idea of a regulatory organization that when HOST will come into force. We really need to bear in mind that what we see right now is a sort of a gold rush and no holds barred approach to the development of AI. And increasingly, there is a need to have some sort of benevolent oversight regulatory body. This is timely and much needed. However, the body will need to have teeth and to be free from political interference. Dominic, thanks for lifting the curtain on exciting developments in quantum computing, highlighting the opportunity that this new technology offers, and pointing to the challenge in terms of policy and regulation. My one concern is that within universities, particularly in the engineering departments, there seems to have been a trend of cutting down the teaching of basic physics. To be able to contribute to your subject, we need that thorough grounding in concepts of physics, not just quantum physics. Bear that in mind. Marlene, we are very grateful that you stayed behind throughout the middle of the night and shared with us this whole view of where SDGs are going and the particular challenges that engineering organizations and engineering programs will have in ensuring that we do produce holistic engineers who are able to contribute towards the sustainable development goals. One of the concerns that has been raised recently is that whereas professional organizations and governments are making commitments towards delivering on sustainable development goals, industrial organizations are still able to get a buy-in from industry into the need to develop engineers who can produce products and services that lead to eventually are meeting the sustainable development goals. Now, clearly, there are two elements that we have to make sure that are available. One is agile business, the awareness of disruptive technologies, and a plan to develop talent that can make the most of it. Once again, on behalf of Dimitra and myself, thank you for our panel, for their sage advice, and for their contributions. Thank you very much indeed.
Thank you.
We'll bring the session to a close. Bye-bye.
Thank you.
Thank you.
Well, thank you very much, Tariq, Dimitra, and the rest of the panel for what was an absolutely fascinating discussion. I learned a huge amount. It's now my honour to introduce you to our keynote speaker, the Right Honourable Kwasi Kwarteng, Secretary of State for Business, Energy and Industrial Strategy. The Secretary of State will be giving his speech by a pre-recorded video. So, Right Honourable Kwasi Kwarteng, Secretary of State, over to you.
Thank you. I'm delighted to be here. Technological innovation can drive not just incremental, but exponential change. In the post-war period, two major technological revolutions have transformed our world and continue to do so. These have been the development of computing technology and the birth of molecular biology. The roots of these technologies were not new, but the circumstances that allowed for their innovation and dramatic acceleration came together in a unique way. Their impact has been global, and their most transformational effects are likely still to come. Emerging technologies will shape the future of our economy, our society, and our security. They have the potential to help us deliver against each of the challenges you have and will be discussing during this conference, and they will shape our lives in the decades ahead. But which technologies hold the greatest potential? I'm proud that this government is investing unprecedented amounts, increasing the amount that we spend on scientific research to £22 billion a year, but as well as cultivating an ecosystem where R&D excellence is paired with a willingness to take risks. We must also prioritise government attention on those technologies that will give us a strategic advantage in meeting the goals or the missions that we must achieve. In the coming weeks, I, as Secretary of State, will publish the government's innovation strategy, which will outline our ambitions in innovation and where we would like to focus our efforts over the next decade. It will create the conditions for increased business investment in R&D and innovation, and it will identify priority technologies that will be key to meeting the challenges that we face, like achieving net zero, for example. These are technologies in which the UK has globally competitive R&D and industrial strength, and which have the greatest potential to unlock economic and societal benefits for the country. These are technologies like advanced materials that can survive in the harshest conditions, allowing us to dig at the bottom of the ocean and to transport the fuels of tomorrow. They can transform the communications industry. They can make manufacturing more efficient, and they can produce batteries and building self-healing roads that can fix our own potholes. AI and quantum will open new frontiers in decision-making and problem-solving. Engineering biology could transform the manufacturing processes that underlie existing industries and offer a critical tool in the fight against climate change. Robotics and smart machines, which will deliver in the near future increasingly autonomous, reconfigurable and scalable smart machines, which will be able to operate safely alongside human beings. We're doing this because we want to celebrate and promote the UK's technological strengths, both domestically and to our international partners. We want to provide a framework for government as a crucial customer for deep tech, and to provide a focus for industry, including to campaign and advocate for the strategic importance of these technologies. As we look at these and other technologies, the UK is in an incredible position of strength. A startup or spin-out is created by a UK university roughly every 2 hours, with the tech startup and scale-up ecosystem valued at about 420 billion. The UK ranks third in the world for deep tech investment by venture capitalists. We have a global lead in AI due to our strengths in frontier computer science and a world-class genomics capability that was recently deployed in the COVID-19 response. We're the third largest biocluster in the world and have made many of the critical discoveries and developments of the modern age, including DNA, genetic engineering and cloning. Public and private investment in the UK's National Quantum Technologies Programme is due to surpass £1 billion by 2024, ensuring that the UK is at the forefront of this technology. But we must do more. Vaccine development and the ventilator challenge have shown the power that government has to convene scientists and innovators and de-risk innovation. We will ensure that we have learned from these lessons, and whether this is through building research and innovation capability to facilitate industry's access to resources such as supercomputing capacity, or science infrastructure, de-risking investment in deep and transformative tech so that the UK finance environment fulfills its potential to support tech companies and allow them to grow in the UK. We want to encourage the adoption and industrialization of deep tech across the UK economy, and by further prioritising within the technology families to ensure we target investment to develop a world-leading edge where it matters the most. The new National Science and Technology Council, chaired by the Prime Minister, will steer this crucial prioritisation process. To conclude, the Prime Minister, the government have been clear on their vision for the UK as a science superpower. That means public and private investment in discovery science and in the wider innovation system, but also in key technologies that will be critical to our ability to meet the missions and challenges ahead. We're taking the necessary steps to ensure that the UK is at the vanguard of these vitally important new technologies. Thank you.
Thank you, Secretary of State. It only remains for me now to say thank you to all our speakers and the chairs today, and a special word of thanks to you, the audience, for your interest, engagement, and your many questions, which has enlivened all of the discussions, as you'll no doubt agree. So that concludes day one of this meeting. Join me again tomorrow at 1 p.m. British Summer Time for the second day of the conference, when we'll be looking in depth at how technology is shaping our energy and education futures. So until then, thank you and goodbye.
Thank you.